In a failing city, a dying supercar is on the ropes. When Detroit's automotive-based economy goes south, the last true muscle car from the Motor City is laid off.
Those were dark days. The economy deteriorated and we were left without a Viper.
In the depths of despair and the middle of bankruptcy, a former designer is thrust into a moment of choice.
It was a strange time. Cars like this are not natural when you're rebuilding a car company.
His solution is simple. Put pen to paper and redesign an icon.
What could be a better symbol of resurgence than bringing back the Viper?
The result, a clandestine project hidden in plain sight that culminates in a machine known the world over simply as the Viper. It's the peak of a 20-year-long quest for American speed. A massive 8.4-liter V10 roaring loudly to the tune of 640 tire-torching horsepower. And 600 foot-pounds of frame-wrenching torque. All of which rockets the machine to a top speed of over 320 kilometers an hour. But as of April 2009, the fifth generation of the Dodge Viper was permanently grounded.
The company went through a bankruptcy and we were left without any prospect of doing a new Viper.
The 2008 financial crisis affects car makers around the globe, forcing Chrysler into bankruptcy, including their Dodge division, which manufactures the Viper.
Chrysler was in financial troubles, the economy was bad.
The automakers were struggling. They were running out of cash. There was talk of bankruptcy.
I actually lived in Detroit during all the bankruptcies, and the mood was just awful.
A bad mood made worse when Chrysler kills the Viper.
I can only imagine that the reason that Chrysler killed the Viper is because it just wasn't selling anymore. It had run its course.
You have to understand the company's going through so much at the time, had so many other priorities.
Ralph Gilles, a former head designer, is thrust into the CEO role for Dodge's SRT performance division.
We were building new plants, we were fixing older cars, really trying to become a relevant car company, at the same time develop a future.
If there's one person in the entire automotive industry that PR people never want in front of a camera, it's Ralph Gilles, because he curses like a sailor, but he tells it like it is.
Tasked with raising the spirits of a now beleaguered company, Ralph decides the best cure is to dream big, supercar big.
The depths of the worst time at the darkest hour, we actually gave a sketch assignment and had a lot of the designers kind of doodle on what the next Viper could look like.
At least they could dream and they could look beyond the bankruptcy.
What better elixir than having a job like that? So, you know, the designers were sketching these beautiful, passionate things, and it was gorgeous.
So gorgeous, in fact, that Ralph Gilles is compelled to do something financially irrational, yet emotionally satisfying. He greenlights a secret project determined to bring the Viper back.
There was a room in the back of the design studio that was under lock and key. The designers would sneak back there and work on Viper concept because it wasn't an approved project.
I remember the first time Ralph called me, he said he wanted to put together a proposal, keep it really quiet.
Nobody had signed off on this. They actually went so far as they built a whole real full-size model, all under Ralph Gilles' direction and completely without the boss's knowledge.
I think Gilles was genius in saying to the guys, all right, look, let's just have some fun, let's see what happens.
Like all good spy thrillers, before you can have a clandestine project, you need a code name.
The term that we had been using in our meetings and in the hallway was, hey, we got to keep this below the radar. And Dick said, well, why don't we call it F117? Because that's the stealth fighter.
A stealth project for a very rowdy machine.
We call it a war room where we kind of write down, here are the things we want the new car to be like, and here are the things we don't want to lose about the old car.
The Viper didn't happen initially through corporate channels.
In typical Viper fashion, the first element discussed is speed.
We wanted to actually reduce the aerodynamic drag so that we could achieve a top speed of 206 miles an hour.
331 kilometers an hour would make Project F117 the fastest production Viper ever. But to do it, the iconic body needs to be completely redesigned.
It was purely driven by what the wind tunnel was telling us. So to hit our top speed target, a lot of the front-end design we had to change.
The team decides to add some more muscle.
We felt like we were toughening it up a little bit.
There's a lot about the car that harks back to another era. I mean, it's a simple, unfettered, uncomplicated machine.
New CEO Ralph Gilles embraces a harsher facade.
It's meant to be flexing its muscles. When you behold a Viper, you see the tension in the system. So we wanted the car to feel heroic.
To save weight, the new body would be made from aerospace-grade carbon fiber, a proper material for a project named after a fighter jet. But redesigned bodywork and materials alone don't get you over 330 kilometers an hour. The covert team would also need more power. Lots more power.
When you achieve speeds in that realm, you have to add a lot of horsepower to go faster.
To build a better afterburner, Ralph turns to the wily old veteran of Viper engines. For the past 20 years, Dick Winkles has continually found more power for the V10 power plant.
Ralph had kind of challenged us for horsepower.
Dick and his team squeeze another 40 horsepower out of the engine, yet they also reduce its weight by almost 12 kilograms.
The engine's outrageous. You know, at 8.4 liters, 512 cubic inches, nobody's doing engines that big.
In the world of supercars, power-to-weight ratios are everything. More power and less weight translates into only one thing: faster acceleration.
It's about motor. I mean, this car is a motor strapped to a transmission and rear-wheel drive, a bunch of seats, and airbags.
The proposed upgrades to the 5th-generation Viper would give it a ratio rivaling million-euro exotics, but at a tenth of the price. Yet high performance alone isn't enough in the rarefied air of the supercar world.
If you think of the original Viper, we spent all the money on the horsepower and going fast, and it was really an engineering-led exercise. You go to today, and that isn't good enough.
In 18 years of production, the Viper averages 1,500 units a year. The expectations for the new Gen 5 machine are set at 2,500.
We've always been a low-volume producer. I mean, the Viper's best year was 3,000 cars.
To be more successful, the new machine needs to appeal to a wider audience.
The biggest challenge that Viper faces is trying to appeal to people who are used to more, shall we say, traditional supercars.
Two very different constituencies must be courted: current owners and drivers who historically don't care for the Viper.
We spent time interviewing competitive owners, people that wouldn't buy a Viper if their life depended on it.
If you lose your core base and you fail to attract new customers, that could be the real danger for them.
The perception of the Viper is a crude, raw sports car.
What makes a Viper is the rawness of it. That's always been the appeal of the car. I mean, you had a big engine, a manual transmission, rear-wheel drive, and it was up to you to make it all work.
For years, the raw, back-to-basics feeling was a selling point.
You have to remember, it didn't have windows, didn't have air conditioning back in the day, so it was a pretty interesting car to own. And that's what people liked about the Viper.
The modern supercar landscape is different. Drivers have evolved. They want more technology, more comfort, and more performance. To succeed, Team Viper will have to walk a very thin line.
We obviously wanted to mature the car. We didn't want to lose that edge that the Viper has.
It's a battle for the soul of the machine.
We knew we had to take the car to the next level in terms of refinement, quality, materials, finish.
Do you continue to be raw or cave along the cutting edge?
We've got a lot of the modern accoutrements, but we haven't lost the soul of the vehicle.
The result is a Project F117 presentation.
We took one of our favorite sketches, we developed it. We kind of had the new car sitting in the middle of the dome. We had the leadership surrounding it.
The team of engineers and designers stand by as the future of Viper is decided.
We were sitting in a very small board meeting, and Ralph Gilles made a very impassioned plea to sell the car, but that wasn't enough.
And it's one of those vehicles, until you really see it and behold it, you don't understand how special it is. So we pulled the drapes off, and the reaction was pretty incredible.
One look gives the new Viper life.
It was an absolute surprise for them, and they walked around, they looked at it, and they said, like, we have to do this. I mean, look at it.
We cried. I mean, you'd worked so hard to get it done, you couldn't help it, you know? We had a nice little celebration.
Gilles' secret project pays off, but a grim reality still remains. How can a car company, riddled with financial woes, in a city devastated by economic collapse, recreate a supercar icon? It's dawn in the Motor City. A place that's had hard times, but is bouncing back. Team Viper is one of the reasons for the resurgence. They've just been given the green light to resurrect an icon. But first, they have to rebuild the once storied program from the ground floor.
Our staff at the time was very, very small. It was a handful. You could count the number of people working on the Viper on one hand. We needed at least more than 10 times that just to get started.
They bring the Connor Avenue assembly plant back to life. It's the last car factory within the Detroit city limits.
In the case of Connor, that was a commitment. We had a choice. We could have moved it out to another plant, but we decided to leave it there because we believe that's part of the story. We're very proud of the fact that Viper is the only car being built in Detroit.
That is the center of the American car industry for so long, and this car is such a throwback to old American muscle car-y coolness that it just makes sense for it to be built in Detroit.
In 2009, when the Viper ceases production, the plant's condition quickly deteriorates.
We had a good year before production of the new car to fix the place up, and that's exactly what we did. We brought the crew back about 8 months early and started refurbishing the plant.
Frankly, I had to chase the raccoons and pigeons and things out of here before we were actually to bring people in here.
To build the new car, the team needs to finalize its design.
When you get approval to go, you don't have all the questions answered. A lot of design work, a lot of engineering work, and a lot of problems to be solved.
With Viper's parent company still recovering from bankruptcy, the budget is tight.
We've got a certain amount of money, a certain amount of time. We try and get the best bang for our buck and make the car really something special.
Time is counting down. The machine is made up of over 3,700 unique parts. The most important are the ones you can touch.
The Viper's impervious to trends. It will remain a Viper, and that's what a Viper's about. It's a finger in the face of convention. It's a finger in the face of society, basically, and how society might change. The Viper's not going to change.
They start by reinventing the Viper's interior.
When the Viper first came around, it wasn't about the interior in the car. The truth is, in the last 20 years, worldwide, the supercar market has changed a lot.
Designer Tomei Jovanowski is the man tasked with bringing the Viper's interior into the modern era.
This is a very iconic vehicle, so with that in mind, redesigning an icon is always a big challenge.
The emphasis is put on one thing: leather, and lots of it.
We wanted to almost revolutionize the interior, but still have a little bit of the feel of the first vehicle.
90% of the new Viper's interior is wrapped in leather.
We can customize it. The owner can make it as unique as they possibly want.
Combined with the exterior options, customers can choose from over 300,000 combinations. With only 26,000 Vipers ever made, that gives owners a high chance of having a one-of-a-kind machine.
We wanted the new car to be as close to a custom car to the individual as possible.
The top-to-bottom redesign also gives the team a chance to incorporate the latest technology. It takes 30 computer modules, 5.8 million lines of code, and over 1.5 kilometers of wire to power the Viper's electronics.
I think that's one of the beauty of the Viper is its simplicity. makes a lot more timeless. So the way we approached it is to have all the technology, but give it almost an analog feel.
After years of avoiding new technologies, the team decides to give the reborn Viper a 21-centimeter screen for driver information. It sounds pretty basic, but Team Viper has its own twist on the instrument panel. An illuminated, snake-faced tachometer when you reach high RPMs.
A big part was to have a vehicle that will still look good 10 years from now or 20 years from now.
While the interior design is an easy upgrade, evolving the machine's exterior is a more challenging task. Engineers modify the body for performance and make minute changes inside a secret wind tunnel. The two-story building features a 6,300 horsepower fan that helps Viper engineers seek the perfect aerodynamic shape.
Swoopy, sexy curves are kind of A, more American, and B, I think easier to do in a wind tunnel. I respect the SRT guys for giving it as many curves as they have and making it this complex shape that's still sultry but doesn't lift off the ground at high speeds.
Wind tunnels are a chance to see not only how air actually moves around the vehicle, but also how the air moves through it.
All the ducts you see on the Viper, all the scoops, all the vents are all functional. We spent a lot of time in the wind tunnel to shape the ducts so they not only look good, but they work well.
All of the vents are actually working. It takes a lot of aerodynamic know-how to get a car to not take off at 200 miles an hour, so to keep it on the ground.
Cutting-edge aerodynamics and an extreme power-to-weight ratio allow the Viper to achieve tremendous performance figures. But not every driver can safely reach those levels without some help.
A major goal was to introduce the modern stability control in a way that allows people who haven't experienced the extremely high limits of a Viper to kind of get into it slowly, experience it, and find out, wow, this car's not going to kill me. It's fun.
Modern stability control assists drivers so that they can push the limits safely.
Stability control is basically a computer that watches everything the car's doing. It's looking at all four wheels. And if you start to spin any tires or you start to get sideways at all, it can apply individual brakes to straighten the car out.
When the Viper first started production in 1992, the mere idea of electronic driving aids fought the back-to-basics approach. Now, it's mandated by the government. To sell a modern Viper, engineers have to add it to the machine. Team Viper's solution is as rebellious as it is simple.
You can dial it back when you want to. You can turn it completely off.
Drivers have an option of which kind of Viper they'd like to drive. Raw or refined.
You can turn it completely off and go do donuts all day long and have a grand time if you want to.
Some high-performance upgrades require computers. Others aren't that technological.
The cross brace, which is now becoming an iconic detail of the new car, actually comes straight from our racing.
The cross brace increases the body's rigidity by 50%, significantly improving the vehicle's handling.
The race car term is that the car just feels so stable and so solid, like a race car.
All that work on the track means nothing if the car doesn't look sexy.
This car evolves, but it evolves in a way that you don't necessarily see. It evolved by becoming more powerful. It evolved by becoming better driving, better handling, better brakes. They improved all of that stuff. But it remained very much a Viper. And the Viper is sort of its own thing.
When it comes to getting a top-of-the-line paint job, the Viper utilizes a factory like no other in the world.
We had to find the perfect facility that was wide open, that would fit the equipment that we needed and have the room that we needed for all the people here, because people are what makes this paint job great.
In a city wrecked by economic downturn, the perfect facility was in the last place you'd expect. a former discount store.
We found a former retail space.
The 11,000 square meter space is home to 115 craftsmen who prep and paint up to 6 Vipers a day.
When we launched a Viper, it came in one color, and that was red. Today, we have upwards of 9, possibly 10 colors at any given time.
There are very few shapes in the automotive world that you can paint any color, no matter how outrageous, and the car still looks good. The Viper's one of them.
It takes 150 man-hours to paint a single car.
The Viper has one of the world's highest paint specifications that are out there. The only way to really achieve the colors and the finish is by people. We find some of the world's best car painters from the custom world, from the concept car and show world, and people who are huge enthusiasts that have that kind of talent and craftsmanship and attention to detail that you just can't get through any kind of automation.
The idea there is, first of all, get the paint quality to be show car level. It's a multi-coat, completely buffed out paint job. I would say today that nobody offers paint quality like we do.
Once the bodywork is done being painted, it's ready to head to the Connor Avenue assembly plant. A factory that was once left for dead, but like the Viper itself, has now risen from the ashes of economic disaster.
We've invested over $12 million in refurbishing the plant. It looks unbelievable.
The 16,000 square meter factory is rebuilt by the same employees that now work on the line. During the factory renovation, each station is customized for comfort and efficiency.
It was very exciting for them. It's almost like they got to renovate their own home before moving in.
The Connor Avenue assembly plant is back in business. Team Viper hopes that they've developed a world-class car. The Connor Avenue assembly plant in Detroit, Michigan has just come back to life. Along with it, the Viper. A small team within the SRT program has worked tirelessly, designing and engineering the rebirth of this American icon.
The employees in this plant are really passionate about this car and about this plant.
The people here are amazing. They're more like family.
And some of them live there. They really, it's their life. It's all they know. They've been there for over 20 years.
The process starts with the machine's beating heart, the engine.
It's an evolution of the engine. It's really evolved over the years.
The Mammoth V10 has been roaring to life for 20 years.
If you would have told me back in 1991, that engine that we'd struggled to get 400 horse out of was going to be making 640 horse one day, I'd have said you were crazy.
The Connor Avenue assembly plant is the only Chrysler facility in the United States that still builds its own engines.
They rely on old, hot rod principles of, guys working on an engine, guys bolting it together and being responsible for that one engine. And that's something unique in the automotive world.
The V10 is a staple of the Viper, and it doesn't have a lot of gizmos on it, but the way the engine makes its power is what's beautiful.
The source of that power starts coming to life when the massive engine block is moved to the line. The enormous crankshaft is installed. It's rotated by the engine's pistons. Those 10 pistons are assembled next to the line. And then installed by hand. Craftsmen attach the oil pan, a massive aluminium flywheel, the first of its kind in a Chrysler product.
Aluminum flywheels, that's something that the hot rod industry has used for years, as a way to decrease the weight and get faster acceleration out of the car.
finally, the cylinder heads. While the engine continues being built, the Viper frame is being prepped for assembly. It starts in a state-of-the-art automated station referred to as Net Form and Pierce.
When it goes into the net form and pierce, it'll measure the frame and it'll make all the necessary adjustments on how the frame is built.
We've added robotics, which is something that the people at the plant were like, what are these things? You know, they've never seen a robot before. But other than the initial robotics, the rest of the plant is still handmade.
The sophisticated robots create mounting points which are accurate to within 1/10 of a millimeter. That's less than 1/8 the thickness of a standard credit card. The frame will begin its journey down the main line, where 30 stations will transform the empty frame into a finished car.
When the frame first hits the line, it receives the differential. It gets a lot of the pieces that are hard to install later. The wiring harnesses, fuel bundles, the brake lines, all of those things.
The smaller pieces are installed with precision to make room for the 8.4-liter engine and its massive 6-speed manual transmission.
It's probably the biggest naturally aspirated engine you can find. I mean, the thing is just an absolute monster.
Most cars, the engine decks from beneath the car. Viper, it actually comes up from above, and it is an amazing thing to see.
Decking a car is an old Detroit auto term for installing the engine and powertrain. Adding the motor and transmission doubles the weight of the car at this stage.
And this motor that is almost bigger than the frame, and you almost are amazed that the thing can fit.
The transmission has to deal with 640 horsepower and, more importantly, 8.4-liter V10 worth of torque. So if you have a dainty little transmission with a dainty little shifter, it'll just rip it apart.
To accompany the massive drivetrain, 355mm Brembo disc brakes are installed, followed by performance shocks.
This car is probably too firm for a lot of drivers, but if you're the guy that goes to the track, you'll appreciate why it's got a crisp ride.
Workers add the custom engine covers and the cross brace. To get the wheels set correctly, craftsmen use something you won't find at the local tire shop.
This is one of the most unique machines in the world. It's a contact aligner. It does all 4 wheels at the same time, and this is what sets the alignment for the vehicle to be an actual racing type vehicle.
Now it's time for custom engineered tires. A quick bit of petrol, some fluids, and an airbox so the machine can breathe.
The vehicle is a rolling chassis. You could literally drive the vehicle without any panels on and go down the road and everything because it's a hot rolling chassis.
In most car factories, the dyno machine is at the end of the line, but not inside Conner Ave. The Viper will stretch its legs for the first time and hit speeds over 100 kilometers an hour.
We're inside the Rolls booth. This is where we test the vehicle for full drivability, for quality, and for braking, for shifting. All of the aspects of the car will be tested.
It's time for a quick ride to final assembly. where the naked chassis transforms from a 300-kilometer-per-hour dune buggy into a real car. It starts with more handwork as the wrapped leather trim pieces are installed. Italian leather seats. The leather-wrapped emergency brake. Finally, the Viper's carbon fiber skin is set in place.
When you see the skin go on, when you see the bright colors go on, it's amazing. It's almost like a model car.
They add the roof, the quarter panels. All of the aerospace-grade panels are fit precisely. If a panel doesn't fit correctly, it comes here to station 270, where they check for dimensional accuracy using a robot-controlled laser.
The car is a hand-fit car. We slow the production process down. It's a 70-minute cycle if you're lucky.
It's the only car still made in Detroit. And they assemble it the slowest way possible. The finishing touch is the redesigned badge. It's the last of 3,700 pieces that make up the machine, all of which are now inspected.
Right now we're at the very end of the final assembly line. The car is completely built at this point, and it will be going from here to final inspection. These robots go in and measure the gap and flush, how the car fits. It scans a laser stripe on the vehicle, and then another camera measures the way the line bends, and then the computers can extrapolate the way that gaps in the flushes are actually performing.
$2,650 liters of recycled water are used to check for leaks. That's the same amount of liquid as in an 8-person hot tub. Finally, every millimeter is looked over by a man and a machine. Workers get one last chance to ensure the Viper is perfect.
It takes approximately 5 days to make a Viper from start to finish.
Viper's built like a model car, and it's really neat to see it come together so quick. And it reminds me of that, you know, that incredible feeling when the car's coming together. You don't need to do these cars. They're not necessarily profitable, but they show the spirit. And that's what the auto industry always was about, you know, is about proving who you are, proving your mettle. It's the gladiator side of a car company.
On a brisk January day in Detroit, Michigan, 1989, Chrysler unveils a radical new concept car. The results will change both Ralph Gilles' life and the American auto industry itself.
I think everyone was thinking, holy shit. They were back on the map, everyone was noticing them, and you look at this thing and say, where did this come from?
At the late 80s, Chrysler wasn't in a great spot, and they needed something to sort of build up the engineers, to tell the world that there were car guys alive at Chrysler. And they came up with this.
So I'm a student going to school. I came to Detroit to be a car designer, and I went to the 1989 Detroit Auto Show. I'll never forget when I saw the Viper there.
Just blew everybody away. It was something that nobody expected.
It stole the show. You know, it was like 10 people deep surrounding the turntable, just staring at the car.
The concept car was the original Viper RT10.
Originally it was the RT10, but there's no emotion in a bunch of letters. Viper. It tells you right out the way it's gonna bite you. It's rough and gruff. It kind of looks snaky. It always did.
At the time, you have to understand, for Chrysler, this was a pretty amazing moment to have something so radical to be seen. It purely was an exercise by a bunch of enthusiasts inside Chrysler that said, hey, let's show the world that our mojo is still there. And they never intended to build a car.
But they did build it, because fans around the world forced them to.
Of course, letters came, people were waving checks, and the company was compelled to do it.
One of those letters is from Graham Henkel.
When I was a 24-year-old engineer coming home, getting my automotive news out of the mailbox, there on the cover is this sleek, sexy sketch of this black Viper, rumored to be the new sports car from Chrysler, and oh my God.
Fast forward to today, where Team Viper is hoping to recreate that same buzz and restore one of the most prolific American supercars ever made.
It's not just a sports car, it's the most extreme, most exaggerated version of a sports car you can possibly get.
When you hit the gas, that thing lifts up and takes off in a straight line. You're just looking at the world rushing past you and these big old fenders sticking up. You can't not smile.
The interior is a lot nicer than the original one. It's still not what you'd call up to the standards of, for example, a Ferrari or some of the other cars, but the Viper's not that expensive either.
At just under €73,000, half the price of any Ferrari or Lamborghini, the SRT Viper is one of the most affordable supercars.
This is the most over-the-top American car you can possibly buy. It's got the fattest tires in the back. It's got a huge hulking V10 under the hood, 8.4 liters worth.
Look, it's the ultimate Acme rocket strapped to the back of Wile E. Coyote.
The crankshaft itself is about the size of your leg. This is just a massive car on a massive scale, and there's really nothing more American than that.
The Viper blasts from 0 to 100 kilometers an hour in just 3.3 seconds. That's 0.2 of a second better than the previous generation. The machine's top speed of over 320 kilometers an hour is a remarkable 14 kilometers per hour faster than its predecessor.
This car does not want to coddle you. It doesn't want to take you to dinner. It wants to strap you down and beat you mercilessly. That's what makes it so much different than anything else.
It's quick. It's really, really quick, and it's basically held back by traction because, I mean, it's got 640 horsepower under the hood. The Viper is still one of the quickest cars on the road.
Current generation Viper will hang with any supercar. Matter of fact, it has records all over the US.
The Generation 5 Viper breaks the track record at the infamous Laguna Seca Raceway in California.
We wanted this to be America's supercar.
An American supercar with a totally manual transmission.
Thank God for it. I mean, paddle shifts might be faster around a track and might be easier to sit in traffic with, but American muscle-y sports cars should have a manual transmission because it makes you work for it. In the case of the Viper, it wants you to break your kneecap. It wants you to break your wrist.
The Generation 5 machine is the most modern and the fastest Viper to date.
SRT will go on and on about their seats being comfortable and the interior being nice. This is not about that at all. It's about going out for a 2-hour drive on a weekend on a nice day and then being exhausted by the time you get home.
It's just staggering. The hood is ridiculously long. The proportions are ridiculous. It's got the short deck, the long hood, the ridiculously huge tires. The car is all ridiculous. I mean, a superhero would drive this car. This is totally the Batmobile.
A supercar for a superhero that started life as a back-to-basics racing machine.
raced at the 24 Hours of Le Mans. And as the car developed, it became better and better to drive. But it remained very much a Viper. Viper is sort of its own thing.
When the Viper debuted in 1989, no one saw it coming. Since then, it's survived the ups and downs of the United States auto industry. And along the way, helped to redefine the American high-performance automotive landscape. But the core of the car's soul is a very simple machine.
And the Viper isn't really high-tech. It's an old-school, huge American engine with rear-wheel drive and a stick shift. It's simple. That's part of its beauty. It's part of what makes it American.
The car's been refined over the years, and this one is the most refined Viper ever, but there's still that rawness to it.
It's a car that should never have been born. A machine that survived an economic collapse and exists purely due to a group of dedicated designers and engineers who wouldn't let their clandestine supercar dream die.
Not many cars are actually built in Detroit anymore. Most of the factories are out in the suburbs. It's a point of pride to be able to say that their coolest car is being built in Detroit, in the Motor City.
When you have the ability to take the car to the limit and you realize how much capability it has, there's nothing like it. And that's the beauty of the Viper.
It's as irresponsible as you were at 17, and it hasn't grown up, and it's never changed, and it probably never will change. It's one of those things that'll never mature.
It's been a long trek to get here, but Ralph Gilles and his team of designers, engineers, and craftsmen have battled the odds to resurrect an American icon.
It kind of scares you to death on the street, and I think that's the point. You want to be scared, you want to be exhilarated, and then the big secret is you get it to a racetrack and it's actually a pussycat. It doesn't do anything you don't want it to do.
This is a stand-in for a mistress. It's a stand-in for drinking too much. It's a stand-in for overconsumption because the car itself is about overconsumption.
The machines are iconic. The badge legendary. For over 100 years, Porsche has successfully built petrol-based sports cars. But now worldwide fossil fuel reserves are dwindling. Danger looms just over the horizon.
The question was not how could a super sports car look like. The basic question was, is there a future of the super sports car at all?
To endure, a team of elite engineers bravely faces the future.
The brand core is racing, is sports cars, and without the core, you cannot survive.
The survival of the company requires reimagining the very concept of the sports car.
Companies like Porsche need a halo car, cars that showcase new technologies.
The brand's future hinges on transforming technology engineered for economy and turning it into pure speed. The result? the Porsche 918 Spider. In the early 21st century, global oil prices surge. Instantaneously, the automotive landscape changes.
Fuel economy is important because of emissions. Frankly, the more fuel you burn, the more you're going to emit. The European legislation in particular is looking at the total amount of gasoline a car burns.
After years of ignoring environmental realities, automakers are forced to act.
The times have changed. The questions which are asked by the publics are totally different.
As fuel economy numbers move to the forefront of consumers' minds, thirsty sports car sales plummet.
This is a company that's known for its sports cars. It now does make SUVs, it makes sedans, but it's the sports cars that define this company.
Overnight, the brand's flagship vehicle, the 911, is in danger of becoming a relic. The future of Porsche is at an impasse.
Everybody is discussing about energy resources and environmental pollution.
Porsche's answer is to boldly introduce a radical new concept car at the 2010 Geneva Motor Show.
We had the plan to show that a super high-performance car can also be super efficient.
The 918 Spider concept car immediately blows the audience away.
The audience did not expect what they see. Nobody wanted to believe that it is possible to have one of the best super sports cars in the world, but on the other hand, having a car which is consuming energy like a mid-size car.
The machine represents an attempt to make a leaner and, more importantly, greener kind of supercar.
When this show car is projected, also a technical concept is lying behind it.
It's something that the board of directors say, well, this is what we want to do.
Immediately, the 918 is greenlit for production.
This is a task. I knew it will be the next step of supercar in Porsche. From the very first day, the hope that it is not just a show car, but that it becomes also serious production.
The target is to have the first machine roll off the assembly line in just over 3 years.
This is a very short time to hit all the deadlines.
There's only one problem. The team behind it doesn't know if they can actually produce it.
There was a clear vision where to go, but in fact no technical solution. And so we sat down on the table a couple of days after the Geneva Motor Show and said, okay, it seems to be we have to make this car. How can we do it?
Dr. Frank Vassler is the man leading the team, transforming a show car into a living, breathing hypercar.
If people know their target and we can visualize it, then it's clearer in their mind every day that we have a very, very tough schedule. So we bought this clock and that was counting down every day.
Just 1,095 days to reinvent the automotive world forever. And perhaps give the brand a new future. The difficult deadline is overshadowed by the project's lofty expectations. The board mandates 2 contradictory targets.
The first is the economy. It must not consume more than 3 liters per 100 kilometers.
3 liters per 100 kilometers is the equivalent to 78 miles per gallon.
The second is to have the best time at the Nürburgring. In our opinion, the Nürburgring is still the principal measure for super sports car.
High performance and high fuel economy typically lie on opposite ends of the automotive spectrum. The Porsche corporate board wants a production machine that can do both.
The show car had only ideas on the technology, but no really engineered solutions.
Every aspect of the new machine either pushes technology forward or forces the team to create it.
There was a small group of engineers working on what could be feasible, how could it work, and of course we're the designers making interior, exterior design.
You have the design and then the hard work starts because you have to fight it through with the engineers, production people and everything.
The big challenge in making a supercar with all this hybrid technology in it is how do you make it all fit within existing supercars? You can't have a supercar the size of a bus.
To meet the deadline, engineers borrow concepts from two of the most famous Porsche platforms ever built. The ultra-exclusive and hallowed Carrera GT supercar and the highly successful RS Spider Le Mans prototype.
We have learned a lot of things in the racing, and we have also learned a lot of things in the Carrera GT. This experience and this knowledge we brought together in the 918.
Only 1,720 units of the Carrera GT were ever built. The machine's value doesn't lie in its exclusivity, but rather the carbon fiber used to build the machine's monocoque frame. Engineers decide that in order to satisfy the 918's two performance targets, they must use a similar strategy to save weight.
The key enemy for a sports car is weight. The concept had to be that the car has to be super light.
The team also borrows the engine technology derived from the RS Spider racing machine.
We have to take a race-bred engine, our V8 engine from our successful race car.
A 608 horsepower, naturally aspirated V8 engine. The proposed powertrain combines the Porsche racing V8 with two electric motors.
It was clear that we want to have three power plants, the combustion engine and two electrical motors, but it was not clear what electrical motors we have to use, where we can get it, what cooling is necessary, what power supply is necessary. That is the task of the realization phase.
In the beginning, we had no idea. But we just started to make it.
When you look at the 918 Spider, you can't help but go, oh my God, are they really going to build this?
There was a lot of passion in the people saying, we show the world it will work.
I remember at the first days of the serious project, I met the guys from the production first, and they said, oh my God, we cannot build this. And I said, yes, we can. We will find a solution.
The theory is clear. The course of action is not. There are less than 700 days left for Porsche to reinvent the supercar. A race the company can't afford to lose.
We really invested heavily and a lot of time in details of the design, as this will be a blueprint for the next sports cars.
It's for sure, from technology point of view, the most ambitious project in the industry.
Although the Porsche brand is known for petrol-based sports cars, it has a unique history with electric motors.
When Ferdinand Porsche started to build his first cars, he used already electric motors. He thought perhaps an e-motor is more reliable than a combustion engine.
In 1900, Ferdinand Porsche builds the world's first electric car. It featured a 2.5 horsepower electric motor and conceptually was ahead of its time.
In the year 1900, there were a lot of people thinking about electrical motors will be the answer. But they had also the big problem where to store the energy. And batteries were unbelievably heavy.
Fast forward more than a century, and engineers at Porsche again face a similar problem.
The lighter a car is, the better. But for a hybrid, it's again different. How big is the battery? How much energy do we carry around?
Engineers determine the 918 needs a 312-cell lithium-ion battery unit that can hold 6.8 kilowatt-hours of power. That's the equivalent of over 2,600 AA alkaline home batteries.
If the battery is too small, then you will not benefit from the power you have in the car.
Engineers face a balancing act. They need powerful batteries to push the performance edge. But, like in Ferdinand Porsche's day, power adds weight. The heavier the machine is, the slower it will go.
A lot of people believe performance is just a number of horsepower. And this is wrong. Power-weight ratio is very important.
When you're trying to determine whether or not the sports car genre can survive, no expense can be spared. Engineers liberally use carbon fiber not only on the outside, but on the inside of the machine as well. The goal? To create an extremely light body to offset the bulk of the batteries. The 918 features state-of-the-art monocoque construction.
Of saying that the passenger cell and all of the main structure of the car is one piece of carbon fiber. And carbon fiber is really carbon fiber reinforced plastic. It's a composite.
It's based on the biggest carbon fiber monocoque in the moment in the super sports car.
Carbon fiber is really carbon fiber reinforced plastic. It's a composite with carbon strands through it that's really strong and very light.
Engineers count every kilo, even in places you may never expect.
You're looking for a fast lap on the Nürburgring, you have to optimize everything.
The wheels are engineered for both speed and efficiency. Built from lightweight magnesium, they are collectively 14 kilograms lighter than traditional wheels.
Look at this wheel, which is the slimmest possible wheel you could do with a very, very special design. It was another thing where we didn't really know whether it would be strong enough to put all the power on the ground.
The result is a chassis and crash structure which weighs a scant 220 kilograms. With full bodywork, powertrain and batteries, the 918 tips the scale at less than 1,700 kilos. The powertrain is the heaviest part of the 918, so engineers put their racing-derived V8 engine on a diet inside a computer environment.
Here is the assembly area from the engine department. So all the prototype engines were built here before they went into the cars. We took basically every part and thought about how we could make it lighter. Maybe you can make this a little bit thinner or maybe another material.
To save weight, the engine uses titanium connecting rods, a carbon fiber airbox, and an oil channel that runs inside of the crankshaft. With the calculations complete, the team tests the new V8 on a state-of-the-art dyno.
High ref engine, that was one of the targets. We wanted to make it 9,000 RPM. On the other hand, we wanted to have a very light engine. The most emotional engine that we could think of.
The team places all that emotion inside the chassis with pure performance in mind.
The general layout of the car, the space where we put in the battery, where the engine is, where the gearbox is, where the driver is sitting, and then lower everything to make the car as stiff as possible.
Nearly 80% of the machine's weight sits below the center line of the car, helping it achieve tremendous cornering speeds on a racetrack.
If your layout is right, then you have the best chance to make a really fast car.
Many auto manufacturers strive to build machines with an equal 50-50 weight distribution between the front and the rear of the machine. The 918 is different. Porsche's engineering team decides to put 57% of the machine's weight in the back. A historical nod to the company's 911 rear-engine knowledge base. While the future of the sports car might be in question, the Porsche philosophy is not. From the very beginning, Porsche has specialized in sporty machines that have the engine in the wrong place compared to conventional cars.
In the back of the 918 Spider is a fairly conventional hybrid system. That means it's a V8 engine that makes all kinds of noises.
It's one of the lightest engines in the Porsche stable, weighing just 140 kilograms. As the team continues to refine the V8 engine, other engineers turn their attention to the two cutting-edge electric motors.
There's an electric motor that can start the engine, or it can power the car.
In the back of the car, engineers pair a 156 horsepower electric motor with the V8. They design the proposed electric power plant in yet another virtual environment. Then they test it in the real world on a unique set of dynos.
The cool bit is up front, where you'd normally have wheels that just steer and brake. There's an electric motor up there, too, and that can power the car. Having an electric motor on the front and this combination of electric and gas in the back makes the 918 Spyder four-wheel drive and really fast.
That 129 horsepower electric motor comes to life inside the ZF factory in Friedrichshafen, Germany. The process starts with the assembly of the engine stator. It's one of two key components that make up an electric motor. The motor uses electricity to create magnetic fields that move around in a circle. A stator is the device that creates this force, and it encourages the rotor, which is connected to the wheels, to follow it.
We are in the factory for the first production step of our stator.
A technician places a lamination stack inside a welding machine. The stack looks like a solid piece, but it's actually 200 sheets of metal.
We start with connecting the coils up to the yoke. 24 coils on one yoke. It makes one stator in every 180 seconds.
Each bundle has 50 windings of wire. The wires are brazed, a process where solder is heated up to 650 degrees Celsius in order to connect two electrodes together.
We go down to 1.5 tenths of a millimeters in tolerance. A third of the thickness of the human hair, for example.
The stator looks complicated, but it's actually the easy part. The rotor is the challenge. It houses the stator. Its job is to use electricity and magnetic force to create movement.
These red parts here, this is the stator, and here we have the rotor, the outer part, that's rotating.
The rotor uses 32 very special magnets to do it.
The force of these magnets we use is about 40 to 60 times higher than the magnets you would use on a refrigerator. They are responsible for the power, the torque you get out of this electric system.
Those magnets are held in check not by bolts, but rather glue. After the stator and rotor are joined, it's time to install the torque damper and the flywheel. Finally, the electric motor is ready to be packaged and shipped off to Zuffenhausen, Germany.
Even if they have the nominal same figure, electric motors are more powerful than a combustion engine.
It takes months to sort out the revolutionary 3-engine setup. However, the solution presents engineers with a new issue.
We need to keep the battery cool. Therefore, we decided to bring all the heat sources away from the battery as far as possible. And that was the birthday of our top pipes.
The placement of the pipes is form following function. Having the exhaust exit from the top of the machine allows both the V8 and the battery to occupy the same space without overheating.
The top pipes are an extremely clever solution, and design-wise, it's really cool.
We thought, what's the shortest way from the exhaust valves to the outside of the car?
In this simulation model, you can see the effects of the hot exhaust air coming out of the top pipes.
The placement of the exhaust pipe solves the heat issue and helps the aerodynamics, but it also creates yet one more challenge. The exhaust gas exceeds 900 degrees Celsius, which will melt the carbon fiber exterior. So the team has to tune the airflow to avoid conflict.
When flowing downwards, the air cools down due to the surrounding flow.
The colleagues from aerodynamics can calculate a lot, and that made it much easier to check if it will work without having a real car in front of you.
In theory, the 918 is now light, powerful, and efficient. However, there's still one massive hurdle for the team to cross. They still need to test it in the real world. The end is in sight for Team 918 as they race towards a tightening deadline. After over a year of research and development, they're finally ready to build a working prototype. Now it's time to test the machine in the real world. With nearly 900 horsepower in a 3-engine vehicle that weighs just under 1,700 kilograms, the word fast may not do the 918 justice. But Team 918 still isn't sure how they'll control all that power.
We talk days and hours on the driving modes, how they should feel like and how the differentiation should be.
They test the cutting-edge driving modes in extreme environments and take prototypes to Sweden, Africa, and Las Vegas.
We tested for 100,000 miles. We have new technology on board that makes it really, really complicated. But we learned week by week, day by day, hour by hour, how to test a hybrid.
After months of trial and error, 5 driving modes are chosen, each activated via buttons on the steering wheel.
We talk in particular about 4 positions of this map switch called E, H, S, and R.
By default, the 918 starts in E-Power mode as a fully electric front-wheel drive only machine.
With this E-Drive mode, the normally aspirated engine is not running.
If a driver pushes beyond 150 kilometers an hour, or if the batteries run low, the V8 engages and the 918 becomes a hybrid. The combustion engine only kicks in when the electric motors need support. The Sport mode allows the 918 to flex its muscles.
We get the full power from the normally aspirated engine, with boost from the e-drive system.
Now the race-bred V8 supplies the majority of the power. The combustion engine isn't the only support system that comes to life in Sport hybrid mode. The Sport hybrid mode also engages the 918's active aerodynamics.
If you drive in a sporty way, then we tune the aerodynamics by raising our wing in the rear.
The tuning is done primarily via a front lip and rear spoiler. The wing has to deal with a tremendous amount of force.
We have air load at high speed from about 3,200 newtons.
3,200 newtons of force is equal to 326 kilograms. The weight of not one German scientist, but 3. The active aerodynamics also help redirect airflow under the machine. Next comes race mode.
It's really a very performant mode.
In race mode, both the combustion and electric motors are geared for maximum performance.
We actually get out everything possible from the e-drive system, even beyond the edges of the original design criteria.
Active aerodynamics also go to the extreme in race mode.
For race mode, you want to have the most downforce possible, and we do that by inclining the wing 8 degrees.
Downforce is an engineering trick that uses the force of air to push a sports car against the ground. At the center of the driving mode selector is a red button, which allows drivers to engage the fifth and final drive mode, the hot lap.
That is the mode for the hot laps on the Nürburgring.
Pressing the red button literally throws caution to the wind, or at least fuel economy. All three engines are allowed to go to the max. None of the computers care about preserving battery charge, pushing the 918 to its 339 kilometers per hour top speed.
People associate hybrid with slow, and that's going to change big time.
The Porsche team has raced against time to meet their design and efficiency goals. Only one target is left.
Everything comes down to a lap time on the Nürburgring.
The lap time is very important for us because the Nürburgring, for us, it's the basic measure for a super sports car.
The Nürburgring is the longest track in the world. This was an old Grand Prix circuit that is ultimately too dangerous to race on. But because the Germans love speed so much, they open it to the public, and they also open it for development.
Located 84 kilometers from Cologne, Germany, the Nürburgring is hallowed ground for automakers.
If you do 5,000 Ks on Nürburgring, it's the same like you make 60,000 on the open road.
A lap of the Nürburgring is every bad road you've ever driven on, plus every good road you've ever driven on, plus every amazing track you've ever driven on. And doing a lap gives you all these different conditions and really tests a car to its limits.
A car what is good on the Nürburgring is good everywhere.
Any brand who wants to make a perfect car comes back to Nürburgring.
No street-legal production car has ever cracked a 7-minute lap time.
We had less than 5 real serious attempts to make this record time.
We have been working towards this day very hard. You know, so many things can go wrong.
After just over 1,000 days, everything comes down to just 48 hours.
One lap, you have to prove everything of the car.
On the first day, the 918 falls short of expectations and a sub-7-minute lap time.
The fastest time of our race drivers was 7:09, 7:07, 7:06, and then I went in the car, made 7:04.
On day 2, the team brings in professional racer Ralph Gilles, a 4-time 24 Hours of Nürburgring winner.
I was sure, and the next day, if the condition is good, I said to Mark, you will go under 7. It's no problem at all.
His second lap was 6 minutes and 57.
He said, listen, boys, think to this day in 38 years. The boys said, why? He said, in 38 years, you are as old as I am today.
The final lap time, 6 minutes and 57 seconds. The fastest lap ever for a street-legal car around the Nürburgring Nordschleife.
This is a number which nobody could imagine, let's say, even 5 years ago.
The 918 has the rare ability to be both a daily driver and a supercar. But now the team has to start building it for customers. And to do that, they'll need a cutting-edge factory. It's taken a team of engineers and designers just over 1,000 days to perfect the 918 supercar. Now they need to figure out how to build it. Zuffenhausen, Germany, has been both the spiritual and literal home of the brand since 1950. Inside of these hallowed halls, Michael Drolshagen is the man in charge of 918 production.
918 Spider is a handmade product. We have no automation inside the workshop.
For years, the Porsche way has targeted assembly methods that maximize production efficiency.
We have to figure out how we can produce a car without the equipment of mass production, but to use mass production tools to improve the highest standard of quality we can get. The biggest challenge was to implement the new technology. It's not only one technology, it's not only a hybrid technology inside the car.
The monocoque is the first piece of cutting-edge technology to arrive at the factory. It's just one of hundreds of new technologies in the car. New tech that requires an extremely efficient factory layout.
Keep in mind, we have only 4,000 meters in square available for the complete pre-production and production of the 918 Spider.
It's a tiny space to handcraft a cutting-edge car. So Drollshagen splits the entire process in half.
On the one side, you have the main line, and on the other hand, the pre-assembly of all our parts.
The first half of the process begins with pre-assembly and the heart of the 918, the 4.6-litre, 608 horsepower, direct-injected internal combustion V8 engine.
We are right now in the engine area where we produce all our engines for the 918 Spider. We pimped it up for the 918. It's a 918 color, acid green.
While the 918 is ultra-modern and filled with new technology, the combustion engine assembly line is absolutely traditional.
We have 7 stations to build an engine. Every engine is built by one person.
It takes the engine builder 20 hours to bring a Porsche V8 to life. The V8 has been modified to be as light as possible.
The thickness of the wall here is around 3 millimeters aluminium.
That's nearly the width of a line drawn by a pencil. The entire power plant weighs just 140 kilograms.
It's more than 100 kilograms lighter than a 911 engine.
Another key area in pre-assembly is the leather trim department.
As you can see here, we produce our leather parts handmade in around 8 hours.
It takes twice as long to handcraft a 918 interior compared to mass-produced Porsches. Everything from seat pads to sun visors is hand-stitched with the greatest of care.
The Sun Advisor, we stitch 220 stitches and more than 90 minutes.
Once pre-assembly is finished, the 918 begins to take form on the main line.
We build the car on the engine, then we fit the parts from inside to outside.
Working inside out is one of the unique concepts behind building the 918. The first step is connecting the V8 engine to the rear electric motor and the dual-clutch gearbox. What Porsche calls the PDK transaxle. The traditional hybrid powertrain is housed in the rear half of the monocoque, which is both light and strong, but isn't structurally sound until the engine is bolted into it.
This is like a bridge for the engine to fit the engine cradle together with the engine, the gearbox and the electric drive.
3 screws on each side turn the engine into a structural component for the vehicle. Then the whole powertrain unit joins the front half of the carbon fiber monocoque at station 2. The engine comes alive once both halves of the machine are put together.
We are now at the 3rd station where we start to build up the car from inside to outside. As you can see with the tubes, wiring harness, air intake, and so on.
Here, the monocoque can be lifted and moved to fit intricate systems like the wiring harness.
The monocoque was 140 kilograms, and it's exactly the same weight of the engine.
Minimizing the weight of both the engine and the monocoque is one of the keys to the 918's performance on a racetrack. Another is keeping the center of gravity low. So they put the heaviest part of the car in the bottom, the battery.
This hole you can see here is for the high voltage battery. And with the cables it's connected to the front electric drive here.
Once they finish wiring the battery, the 918 is ready for the last of its 3 power plants. The front electric engine. It arrives at the line already pre-assembled to the front suspension.
We have 3 hearts inside the car. The V8 engine and 2 electric drives. And we have a 4-wheel drive only by cable.
There is no traditional drive shaft connecting the engine to all 4 wheels. The 4-wheel drive system is run by a cable. The computer can continually vary the power split between the front and rear wheels.
What you can see here is the brake system of the 918 Spider.
They very carefully install the rear brakes by hand. The 406mm custom Brembo ceramic rotors work in concert with the electric drive system to recuperate energy.
A big advantage of the cars, you have not only the standard braking system available, you have in addition 2 braking systems with the 2 electric drives.
While the 887 horsepower pushes the 918 to an insane top speed, the regenerative braking system can convert stopping energy into 230 kilowatts of power. That's enough power to run 183 American houses.
The benefit of a hybrid system is that you're recapturing a lot of the energy that would have gone wasted into braking.
Slam on the brakes, and the 918 goes from 100 kilometers an hour to a dead stop in 28.6 meters. Roughly 2/5 the wingspan of a 747 jumbo jet. Once the mechanical pieces are set, the 918 receives its bodywork. Now the machine is ready for perhaps its most famous part, the badge. A symbol that combines the historic colors of southern Germany and a black stallion, which has been an iconic fixture in Stuttgart's coat of arms since the 14th century. But the 918 isn't quite finished. It still needs a very important alignment check, because the rear axles feature electromechanical actuators that enable it to do something unique: steer the car from the very back. The rear wheels can turn up to 3 degrees in the same direction as the front wheels for enhanced stability at high speeds. Finally, after 3 years of research and development and countless hours on the assembly line, the very first 918 ever built, serial number 001, is ready. A car intended for Ferdinand Porsche's grandson.
Normally we do not talk about our customers, but 001 is Wolfgang Porsche. He of course ordered number 1 and makes the team extremely proud that the first car will go to family number.
The very last station on the line is one of the most unique in the automotive world, because it's the quietest and perhaps one of the most expensive. The 918 has a base price of 636,000 euros.
I think that most automotive engineers are hedging their bets and saying, right now, electricity is probably the best way for us to go for all of our cars.
Turn the key, and the latest Porsche supercar simply hums along, with the electric engines doing all the work.
You're not buying a 918 Spider to go as slow as possible in traffic and use the least amount of fuel. Everyone who buys this car is gonna drive it like a total maniac because that's exactly what it was intended to do.
Put the pedal to the metal, and all 3 motors come roaring to life.
anytime you get into an electrically powered car, whether it's just a pure electric vehicle or a hybrid that's electric intense, it is immediate psychotic acceleration. It's unlike any gas engine.
After just one wheel rotation, the 918 is already going over 25 kilometers an hour.
The difference between turbo lag and a normally aspirated racing engine is this big. The difference between a gas engine and an electric car is that big.
The cutting-edge hybrid powertrain produces an astounding 887 horsepower. At its peak output, the 918's 3 power plants produce 1,280 Newton-meters of torque. The 918 catapults from 0 to 100 kilometers per hour in just 2.2 seconds.
The 918 Spider gets to 60 faster than that.
At 300 kilometers an hour, the 918 covers 42 meters in half a second. Half the short side of a New York City block. It goes 0 to 200 kilometers an hour in just 7.3 seconds. Never slowing down until its maximum speed of 339 kilometers an hour. Yet the most impressive number could be its fuel economy. The 918 uses just 3 liters per 100 kilometers. Unheard of for a sports car.
The interesting twist on this one is that not only is it the state-of-the-art in speed, but it's also the state-of-the-art in getting good ratings on fuel economy challenges.
In the end, if it's then fun to drive, that is really an opener for new technology. And from that point of view, I think the 918 Spider is an opener for really a new decade of super sports cars.
First, it was a dream. Then it was a concept car. Now it's simply the world's fastest four-wheel drive hybrid supercar.
It's always a challenge, it's always something interesting, sometimes it's unexpected. If you're working for Porsche, it's never a project that will be boring.
It is definitely not certain that electricity is the future. It is a future, I think. But it looks like every probable direction is heading towards electric.
For over 100 years, Maserati has specialized in handcrafting high-performance, luxurious four-seat machines. And they've done it while operating in the shadow of the most iconic Italian car makers in the world.
Maserati's known for being the kid brother to Ferrari.
Now, the time has come for the brand to make a name for itself.
We went back to look at how we took inspiration for doing the Maserati of the future.
Their goal, to combine Italian sex appeal with supercar performance inside of a four-door machine, and then shrink the supercar.
Maserati needs to look amazing and grab your attention, otherwise it doesn't have a reason to exist.
It's a bold move designed to open up new markets and increase production tenfold.
It's a little bit ambitious, but it's also a little Italian in its drama.
The future of Maserati hangs in the balance, and it's called the Ghibli. In the world of supercars, there is perhaps no more competitive location than northern Italy. It's home to Ferrari, Lamborghini, Pagani, and Maserati. Just as the country has faced ups and downs, so too has its automotive industry.
Maserati went through a lot of hard times in the 60s and 70s and 80s. And the cars were basically cobbled together.
In 1993, after years of fits and starts and poorly produced machines, Italian auto conglomerate Fiat purchases the Maserati brand. They place the company under the direction of their most famous marque, Ferrari.
Ferrari took over, basically gutted it, and changed the way that they put together cars.
It's a luxury 1-2 punch for the wealthy, Ferrari for supercars and Maserati for super saloons.
Maserati was the car you drive every day and then get in your Ferraris on the weekends.
After decades of living in the shadows, Maserati is ready to call attention to itself.
We started to think how to turn over the Maserati, and we went back to look how we took inspiration for doing the Maserati of the future.
For years, the company has had success with their flagship model, a luxury saloon called the Quattroporte. But in order to expand, it's clear the brand needs to do something unexpected.
The big problem is that Maserati just hasn't had the cars. I mean, they've had a really big sedan that was beautiful and stunning, but getting old.
We have meeting, the project team gets together and lines up the future of the brand. What will be the car that we have to have in the portfolio?
The challenge here for Maserati is simple. Maserati needs to sell more cars.
For the past decade, Maserati has sold just over 6,000 cars per year. The company takes their flagship supercar and shrinks it into a smaller, more affordable package.
Maserati needs a car that sells more, and a midsize sedan is the right place to be. It's never quite so easy as saying, you know, honey, I shrunk the Quattroporte.
The smaller model is coined the Ghibli, tracing back to Maserati's glory days.
Ghibli is an important historic name for Maserati. And the Ghibli was a coupe that was a competitor to such cars as the Miura from Lamborghini or the Daytona from Ferrari, and was one of the most performing and exclusive two-seater coupe of that period.
Paired with the launch of a revamped Quattroporte, the Ghibli is a key element in the brand's expansion plans.
The two projects were 6 months one from the other. We had the chance to think about the two cars as two ambassadors of the Maserati design.
Starting at €52,000, the Ghibli enters territory loaded with steep international competition. Any misstep will spell disaster for the brand.
Once you move under $100,000, you start to compete with cars like the BMW 5 Series, the Mercedes-Benz E-Class, and the Audi A6. And those cars sell in serious numbers, and that's what Maserati's going for.
The Ghibli's goal is to open up new markets and increase sales to 50,000 units.
The Ghibli enters the brand in an area it has never been present before, with the ambition to raise the number of Maserati from less than 10,000 to more than 50,000. So it's a big bet.
That big bet starts at the Fiat Design Center in Torino, Italy. A cutting-edge facility that the public normally never gets to see. It's here where 200 men and women with an average age of just 37 determine the future of the brand. The process starts with a collage. Image boards help designers define the brand's ideals. Since 2011, the man with the final say is Lorenzo Ramaciotti, the head of design for every single Fiat brand, including Ferrari and Maserati.
Designing a car is a very complex activity, but if the foundations are good, it's much more easy to get to a satisfactory result. And in this case, we had a very good foundation from the mechanical layout.
Ramaciotti decides that in order to differentiate the two machines, his design team must focus the Quattroporte on elegance while building the Ghibli around speed.
We decided to go with the Ghibli more in the sporty direction.
The process takes months, full of long days and long nights. As the pressure continues to mount for the brand to increase Maserati's sales, designers get to work shrinking their flagship. Cutting the saloon down begins inside the Fiat virtual reality room.
Hi, good morning.
Hi, good morning.
Ciao.
How are you?
Where the team literally goes over the machine point by point. To give the Ghibli a sporty feel, designers shrink the machine's wheelbase, the distance between the front and rear wheels. The team cuts the machine down by 173 millimeters, which is nearly the height of a wine glass.
There's always a big problem making a sporty sedan because if you make it too sporty, the back seat doesn't work. And there's a compromise there. You're never going to have a sedan that looks like a supercar from every angle and still be usable.
To double-check the basic proportions, designers moved to a more traditional form of streamlining. They tape the body by hand to ensure that each line is perfect.
The idea is to go a little bit back to the sporty cars of Maserati of the 60s. You can do, obviously, with the engine, suspension, and other things, but to transfer this feeling with the design is not easy.
While the most striking change is the Ghibli's size, the team knows that it's the interior that will sell the car to a luxury crowd.
We took inspiration from everything from nature, from architecture, in order to be different.
They use a full-size model of the interior cockpit, called a design buck, to plan the inside of the cabin.
One of the inspiration was the helmet of a warrior. For example, you can see these elements, it looks like the mask.
No matter the machine's proportions, it still requires an Italian touch of style. On the other side of the studio, that look and feel comes to life thanks to image boards that define potential customers.
We can have different kind of people driving the car. This is, for instance, a person that's like doing lots of sport and that has a very outdoor lifestyle, sense of freedom and the challenge and all this. We try to look at the details of all the accessories that they could be wearing. We try then to find materials that could be matching and not just in the colors atmosphere, but also in the attitude.
The result is an Italian interior tailored for a mass-market audience.
Because it's very important to us to see the matching of the colors, if something could work together, because sometimes it works in your mind, but then when you see it in the reality, it doesn't.
While shrinking the car is one challenge, achieving supercar performance on a mid-sized saloon budget is another. Engineers figure out how to do it inside of the Maserati Corsa facility, located just outside of Modena, Italy.
There are demands, both on the design you see and on the design you don't see for reaching supercar performance.
Right away, engineers know outright efficiency is essential.
The supercar have a super performance. They also have a super request in the sense that you have to have a very good aerodynamic performance in terms of drag resistance.
To compete with supercars at a fraction of the price, designers work endlessly in the wind tunnel to find the lowest drag coefficient possible. Drag represents the amount of resistance an object faces as it travels through the air. The lower the drag, the easier it is for the car to cut through the wind. And the faster it goes.
If the car has a lot of drag, you spend a lot of money to run it and the speed is not so high.
Meanwhile, engineers work to keep weight down with affordable materials.
What you can see, and is in this car is, that goes a little beyond design, is the fight for weight reduction.
The team engineers the majority of the machine out of aluminium, including the hood, doors, boot lid, and fenders. But saving weight goes more than skin deep.
And this was also to reach the performance through the reduction of weight.
Reducing weight has been a hallmark of Italian supercars for decades. Maserati has a unique knowledge with the material because it is the oldest automotive marque in La Terra dei Motori, otherwise known as Italy's Motor Valley. The company was founded in 1914 by 7 brothers. 6 were car enthusiasts, 1 was an artist. For the next 12 years, the brothers modify cars in a quest for speed. But in 1926, they branch out and build their very first car from the ground up, the Type 26. It wins its very first race, the Targa Florio, one of the most dangerous races in the world. The Type 26 was the very first Maserati to feature a trident on the grille.
7 brothers worked in the company, except one that was an artist. And the brother asked him to design the logo for their new company, and he took inspiration from the trident that is in the hands of a statue in Bologna.
A logo inspired by the Neptune statue in Bologna's Piazza Maggiore, and featured prominently on the Maserati factory in Modena, Italy. The area is hallowed ground for supercar fans, but the Maserati factory in Modena was built when the city was still farmland.
This is the birthplace of the modern supercar, and Maserati is among those brands.
Today, Modena is a bustling city. There's no place left for the brand to expand. Maserati has embarked on a new chapter with a fresh take on the luxury saloon market. But they've outgrown the company's historic home in Modena, Italy. To build the Ghibli, they need a new factory. So the team zeroes in on another Italian automotive center.
Torino is a kind of counterpart for Detroit because it's really a motor city. It's been living around car manufacturing plants for almost 1 century.
You have your Silicon Valley in California for computer, software, etc. Here is an area where most of the sportive engines are born, is northern Italy.
In order to have any chance of returning to the forefront of Italian motoring, Maserati must push for exponential growth.
In order to survive, Maserati needs to sell more cars.
However, dramatic expansion is not without its challenges.
To produce a car with this kind of volume, we need to have a complete new plan.
So it was absolutely impossible to foresee an increase in production from 10,000 to 50,000. So there was the need for a plant where the 2 cars, the Quattroporte and the Ghibli, that share many components in technical terms, could be produced together on the same flexible line.
The solution is to move production from Modena to Grugliasco, Turin. The facility had been shut for 3 years before Maserati's corporate parent, Fiat, spends €1 billion to bring it back to life.
This was a plant that produced cars starting from 1963. Then in 2006 they stopped to produce, and for 5 years the plant was closed. And in 2011 we bought this plant, and now we are producing new Maserati.
They had already a paint shop that was possible to convert, and finally we took the decision to rehaul completely the plant.
We removed all the equipment in less than 1 year.
The new Grugliasco plant has the capacity to build up to 200 units per day using 3 shifts.
Here we have body white, we have paint shop, we have assembly shop. All the plant is dedicated to produce Ghibli and Quattroporte. You think that 2 years ago this was a closed plant with nothing, and now we are producing 140 cars per day with more than 2,000 people involved in the production. Is clearly a very, very good thing.
The Grugliasco factory is a new home for an old brand. But they start building the Ghibli in a very traditional way. By manufacturing the frame inside of the state-of-the-art body shop, where the first step is building sub-assemblies for the front and rear portions of the chassis. Once completed, each subassembly heads to the main welding line, where Ghibli bodies come to life one spark at a time. There are more than 1,000 welds in each machine, and each weld uses enough electricity to power a house for a week. All of the complicated aluminium engineering pays off. The Ghibli weighs 50 kilograms less than its big brother, the Quattroporte. Less weight helps acceleration. The fastest Ghibli does 0 to 100 kilometers per hour in just 4.8 seconds, a heady time for a family saloon. But speed alone isn't enough when you're trying to sell to new markets. The Ghibli must also look the part. It's the Italian styling that adds the required supercar glamour.
We are always on the blade, because it's not something that is so extreme. It's classic, but not static. Maserati want to put this kind of dynamic proportion on the sedan, and this is the big difference.
It's just a different kind of experience from the German stuff. There's a little bit more art in there than science.
Bringing the look and feel of a sexy Italian supercar to the realm of everyday drivers is not as easy as it seems. It introduces the engineering team to a new kind of challenge.
One of the challenges for Maserati in transitioning from supercar to a supercar sedan is that they have to think about more conventional things like putting a child seat in the back or keeping people safe.
To be competitive in the mid-size luxury saloon market, engineers and designers need to focus just as much on safety as high performance. That safety is tested here, inside a crash test facility. To meet modern crash standards, the Ghibli chassis is built around a safety cell. The airbags are fully deployed in 50 milliseconds, 1/3 of the time it takes for an average car crash, and literally the time it takes to blink an eye. The safety cell is built with a combination of different steel and aluminium alloys in order to channel the energy most effectively during a crash. That's important because the forces acting on a car during a crash can exceed 550 kilonewtons. That's over 30 times the weight of the Ghibli itself, and 500 times the force of gravity. With the machine's safety requirements solved, the team turns its attention to more traditional Italian concerns.
This car, there was not inside of the Maserati world. There is a combination of proportions and of design language.
The elements are the same elements we use to build the Maserati image, but are played in a much more aggressive and strong way.
The Ghibli looks like a classic Italian supercar. Maserati has shrunken their supercar in order to design and engineer a new mid-sized saloon. To bring it to market, they've had to rebuild a factory. But the Ghibli still needs a cutting-edge power plant in order to compete on the world stage. Paolo Martinelli, a former Ferrari Formula One engine designer, is the man tasked with bringing not one, but two new Maserati power plants to life.
main goal is to realize an engine with absolutely top performances in a range of volume that was a step ahead.
The brand builds two V6 engines, a fuel-efficient diesel and a petrol-based variant built with performance in mind. It's no surprise where that engine comes from.
Maserati engine is manufactured 100% in Maranello.
Maranello, Italy is the home of Ferrari and where all Maserati engines have been built since 2002. Martinelli decides it's the best place to build the new, naturally aspirated V6 engine. A 3-litre power plant that cranks out a potent 404 horsepower.
It brings a lot of the racing heritage of Maserati, racing heritage of Ferrari into this car.
Showcasing the brand's racing heritage was Maserati's most important goal. The new Ghibli, however, is entering a market where fuel economy is just as important as outright performance. For the first time in the marque's history, they introduce a diesel engine.
Yeah, putting a diesel in it is a totally different approach, but they need that engine to sell in Europe.
The twin-turbocharged 3-litre V6 is built at the VM Motori plant in Cento, Italy.
I mean, they don't hand-build these cars the same way they built Maseratis in the 1960s, but it's the same people with the same kind of passion for the cars. And if you ever go to an Italian car factory, these people are passionate.
Both engines have supercar sensibilities. The question is whether or not the brand can build enough for mass production.
The challenge is to realize a project for a sportive engine, but in a bigger volume.
They made it very public that within 5 years, they wanted to sell 50,000 cars worldwide. Now, Maserati is a company that struggled to sell 5,000 cars in a good year. 10 times their volume is a very ambitious goal. But a car like this, if it takes off, if it starts selling well, will be a crucial part of that.
Engineers test both engines repeatedly in a climate-controlled environment that replicates the warmest and coldest places on the planet.
Of course, there are data that we normally call it computational fluid dynamic.
The room ranges from minus 40 degrees centigrade all the way to 50 degrees centigrade. They tune the signature Maserati sound as well.
Maserati, I think, is a nice car in terms of styling and in terms of performances, and with the feeling and the sound, for instance, of a Maserati. One of the characteristics is when you push the gas pedal, your exhaust system is able to inform you that you are driving a Maserati.
While the team continues to refine the two engines, at the Grugliasco factory in a cutting-edge paint shop, bare Ghibli bodies get ready for some color. First, the aluminium body is prepped. Body gaps are measured by hand to ensure perfect panel alignment.
Look, Italian is all about sex appeal. A lot of it doesn't really matter what is underneath the car. It's that appeal when you first look at it. And the Ghibli certainly looks different.
Once the bodywork passes quality control, the bare metal is ready to be dipped in an electrochemical bath that prevents rust.
Here the car is coming from 7 different baths to prepare the body for the very first paint. We gave a negative charge to the body and a positive one to the bath. With this electric charge, the paint can stick very strong to the body. After this 10 to 12 minutes bath, the car is ready for a second wash and to oven treatment to dry the paint coat.
Now it's time for some paint. The Ghibli is available in 13 colors, each of which is applied by a combination of artisan painters and high-tech robots. The robots spin paint at 45,000 revolutions a minute, and they're extremely precise. The margin for error in the paint shop is plus or minus 0.5 millionth of a centimeter. That's a little wider than a human hair. At the last station, each body gets a clear coat.
Robots do make some things more efficient, but it's not a way that you would think of everything is being done by robots. And they're checking them, and they're really working on them, and then they're moving on to the next. It's a much slower process.
Finally, each body is polished by hand until there's a mirror-like finish. Now the newly painted body is ready to head to the line.
This is the first station of our assembly shop. We have Quattroporte and Ghibli. We produce both in the same line. There is a Ghibli that arrived from paint shop.
Here the car dropped down from the chain. In the first 3 stations, we assemble the cables.
While both vehicles share one line, the emphasis on individual quality and care is paramount.
For us, it was important to have a plan that is according with the history of Maseratis. Accuracy in the assembly is mandatory for a kind of car like this, a supercar. The most important thing that we use a lot of very skilled workers have the ability to assure the very good quality that we need.
While building the factory took almost a year, it takes even longer to train a new workforce to operate it.
300,000 hours of training because we need to have people that know very well our production method.
A production method that's based on the brand's historic roots.
So that whole kind of feeling of old world craftsmanship.
A tradition that continues on the dashboard sub-assembly line, where they installed a steering column, wiring harness, then it's time for the instrument panel, which features a high-tech touch control screen and Bowers & Wilkes audio system. Once complete, the dashboard is sent to the line. It's one of 3,000 parts that must be coordinated within the factory. Then it's time for the interior, which features an advanced Wi-Fi system intended to lure a much younger demographic. Each system is installed by hand. A historic Maserati building trait that's hard to continue as the brand tries to increase volume.
I've never tried to build on this scale, so yet they also need to make sure the quality stays high. And that's a little bit hard to do when you've got to do so many cars and you've got to turn them over so much more quickly.
Each body is transported across the factory by a series of yellow hooks.
These yellow hooks allows us to have always a perfect position for the workers.
The hooks can rotate nearly 90 degrees.
We can also rotate the car to work on the bottom part of the body and the pipes of the brake system. With this chain, we can also transport all the bodies along the chassis line and also send the car to the last station of the final line.
Maserati inherited the C-hook technology from Ferrari. And on the other side of the factory, engines arrive from Maranello. Each engine's treated with care as it's escorted to the line.
We're in the first station of the powertrain area, and we put the engine together with the gearbox.
So we received this engine from Ferrari. This kind of engine and this kind of gearbox is one of the reasons of the success of this car.
You could build anything in Maranello and say, hey, Ferrari built it, and it would be amazing. It's the Ferrari engine. They are the engine gods. So if they're building this V6, why wouldn't you tell the world?
They connect it to a ZF 8-speed automatic transmission. Once pre-assembled, the engine is sent to the drivetrain line.
We're in the center of the powertrain area. Here we put together the front and rear suspension, the engine, and the gear shaft.
Workers attach the exhaust pipes. The front suspension is bolted on. Then, radiators are installed. The half-built drivetrain is then transferred to another line, where craftsmen install the back half of the unique Maserati exhaust system. Workers install the drive shaft. Fuel cell. Once the drivetrain is built up, it's ready to meet the body.
We're in the middle of chassis line. This is the marriage station. Here we put together the body and all the powertrain components.
The drivetrain joins the body of the car and is held together by just 18 bolts. Bolts that the brand is counting on for global growth.
This is probably the entry-level Italian exotic car. Otherwise, you're spending 6 figures, and this car's under 6 figures, and there just aren't any other players in that segment from Italy.
Maserati's plans are clear. For decades, the Trident has stood for Italian luxury. But culture constantly evolves. Symbols alone don't get the job done. Maserati's answer is to gamble on the Ghibli.
And you want to do cars that can stand a long time without getting dated or getting old. We want to make kind of instant classic.
Inside the Grugliasco factory, that instant classic is taking shape one bumper at a time.
We will assemble the front and rear bumpers. and wheels.
With the bodywork finished, it's time for some hot wheels. Then, the luxury seats. And doors. The Ghibli is almost ready for prime time. But before it can leave the factory, it has to hit the road.
We are in front of the rolling test bench. We test 100% of our car till a top speed of 140 kilometers per hour. This test is to verify the perfect adjustment of the engine shaft.
Once the Ghibli has put the pedal to the metal, it's time for a bump in the road. A 50-kilometer-long pothole. Followed by a lengthy shower to look for leaks.
We are in front of the water test. We clean the car after the road test in the first part of the tunnel. And the second part of this machine is to test the waterproof sealing of the car.
A few more final checks, and the machine is ready for the real world. Where its first task will be to broaden the brand's appeal and lead their growth.
Maserati is not super well known. You hear the name Maserati and it evokes something Italian, something expensive, but not necessarily a four-door sedan.
Maserati exists in this strange kind of place where everyone associates it with Ferrari, and the biggest challenge for Maserati is getting people to realize that it's not a ridiculously expensive car.
Starting at 52,000 euros, the machine thrusts the marque into new territory that's radically different than Ferrari, its corporate parent.
BMWs and Mercedes and Audis are just kind of everywhere these days. If you want to stand out and have something different, you can have a Maserati. That's a big difference.
That big difference has led to a very big bet, all in the hopes of growing tenfold.
Maserati wants to sell a lot of cars because you need to sell a lot of cars to keep your profits up and run a successful business.
Maserati hopes to go from 5,000 units a year to 50,000.
They need to weigh the pros and cons of moving down market. There's definitely more of a con, especially if they're chasing 50,000 sales.
To chase sales, the brand is banking on its Italian heritage.
Cars have kind of picked up traits of their home countries. Italian cars have always had this idea of passionate and very beautiful and elegant to look at.
That Italian passion culminates inside of the engine bay, where the Ferrari-built twin-turbo V6 generates 404 horsepower. The engine reaches 90% of its 550 Newton-meters of torque at just 4,500 RPM.
If you keep your foot in it, it'll surprise you at how quickly it accelerates. Once you rev it past 4 grand or 5 grand, the thing just comes alive. Which is a really Italian thing, is a high revving engine.
Put your foot down, and Ghibli screams from 0 to 60 in just under 4.8 seconds.
It's an emotional experience because you're waiting for it, and then boom, it hits.
It's very clear when you get in the Ghibli that somebody paid attention to the way that engine sounds and the way the sound responds to what the transmission's doing.
Keep your foot down long enough and the Ghibli will reach a top speed of 284 kilometers an hour.
The Ghibli's a quietly fast car. It sneaks up on you. You don't realize just how quickly you're going. You watch that needle on the speedometer go, how did I get here? It pulls and pulls and pulls.
Lightweight construction paired with 50-50 weight distribution help give the Ghibli a sporty feel on the track.
One of the great things about Italian cars in general, and Maserati does this very well, is that they keep this emotional connection in the vehicle. You can get in some cars, and it's a piece of machinery. It gets you from point A to point B, and does it just fine, does it perfectly reliable, but there's nothing particularly exciting about it. You don't walk in your garage every day and smile.
After years of planning, the Ghibli is ready to add a touch of Italian flair to the mid-size saloon market. Where the Maserati's bold gamble to expand pays off is now up to customers around the world.
Supercars are built to a standard. They're not built to a price. You start building a car like this that has to compete in the $50,000 to $100,000 segment, you have to start building things to a price, and you have to start cutting corners. It's not necessarily a bad thing, it's just a bigger challenge.
The car's a soul to it. It wants to be driven. It rewards you when you go around a corner and you push it. You get this great sound.
The draw of this car is unquestionably the way it looks and the emotions it evokes. It looks, it sounds, it smells, it feels. That's what the Ghibli is about. If you don't want any of that in your car, there are plenty of other options. If you want something different, something that makes you feel special every day, that's why you bought the Maserati.
It's synonymous with sophisticated elegance, high performance, and secret agents. For over 100 years, Aston Martin has made distinguished sports cars. But now, this tiny British brand stands alone.
We are a David versus a Goliath.
Battling multinational conglomerates in an ever-changing world.
Aston Martin has no margin for error.
To survive, they need a new machine.
We are it. There is no helper or big brother.
A small but dedicated team looks to the past, only to find salvation in an old American hot rodder's trick.
I was absolutely adamant, we're going to make this do 200 miles an hour.
A uniquely English machine called the V12 Vantage S. In 2007, Aston Martin stands as one of the top European sports car manufacturers in the world. Winning both on the racetrack and also on the showroom floor.
We were really into our stride and producing over 7,000 cars, and we established the DB9 as the new icon, a super cool GT. We got the V8 Vantage in production, and we established what we call the new era.
Almost without warning, the world economy collapses. Overnight, Aston Martin loses its empire.
Some challenges in the market for sure from 2008 onwards, a global recession.
It's a global recession that sends car makers around the world into a tailspin. For Aston Martin, it's now do or die.
Aston Martin is one of the very few independent, really small car makers.
Most supercar manufacturers are owned by worldwide conglomerates. But Aston Martin has no corporate safety net. The company's next move could be its last.
No matter what's going on in the company and the economy and whatever, these guys got to be thinking, I want to build a sports car, I want to build a sports car. And well, they did.
Now, for the first time in over 20 years, its success or failure rests solely in British hands.
They have to fight for their own little niche. They don't have economies of scale, which other manufacturers have, so they have to pay more for every single part that they develop for their cars.
So what Aston has done is sort of repurpose the same architecture and their same engine to make new things.
Lead designer Marek Reichman itches to push the brand forward.
We've always had a policy of thinking about what could we do next with the assets that we have around us. What would be exciting?
With limited money to build a new machine from the ground up, Reitman has to do a lot with a little.
The idea was, well, what if we put the V12 engine into the Vantage? How could we make that work?
Squeezing the brand's biggest engine into one of its smallest and oldest chassis is a daring proposition. Yet the notion ignites a passion for speed.
That genesis, absolutely, of Ian coming along and saying, hey, you know, we have this idea, we talked together, said, this will be an amazing car to do.
The engineering team quickly sets its sights on creating a bold goal.
When we're laying down the targets for the V12 Vantage S, I was absolutely adamant to the guys, we're going to make this do 200 miles an hour.
An outrageous top speed isn't the only objective.
We wanted to get below the magic 4 seconds of 0 to 60s. So it really came out of a small group of guys free thinking, but once we got hold of the concept, we thought, yeah, this is a serious project and a serious car.
With the performance targets set, the design team faces a unique challenge. How to take an existing and universally applauded supercar and fit a substantially larger engine inside it.
We had a VMAX target. All those were defined. We create the sketch, and that sketch has to look like an Aston Martin.
Making an Aston Martin look like an Aston Martin is no easy task.
Your first reaction has to be, it's beautiful.
It takes time to find the right balance of beautiful.
If I was to describe the thing that we had to win, it was about making sure that proportion was absolutely perfect. So the fight was for perfection.
It's a distinctly British form of perfection that starts in a very old world way.
All Aston Martins start with a sketch. In my mind, that immediately starts to give you a proportion. Within that proportion, you have to fit the person. So you can then start to realize where the front wheel is, where the rear wheel is, where the occupant will sit, and you can start to sketch. You can start to have an idea of the form, the language of the car.
That language is the key to Aston's rebirth. And it's all due to a time-honored process.
That sketch then becomes a three-dimensional scale model.
Designers design a lot of stuff on computers, but you can't touch what's on the computer screen. But you can touch what's in clay.
At first, they create an 8-scale model. It's a fast way to bring the language of the car to life.
At that point, we can then start to scan that three-dimensional form. The CAD doesn't understand whether this is a scale model or not, because we can convert the scale to full size, so we can turn a 10mm square into a 100mm square. So immediately then we have a surface.
Once the surface becomes digital, the team can look for the most minute imperfections.
Our role is to get the scan data and the nuances that are done physically by the clay modeler. Our job is to refine those. Then we go back to the physical world to make sure what we've done is correct.
Modelers work tirelessly to perfect the shape in the real world. Handcrafting each sensuous curve in clay on a life-size model.
I'm not a designer, but it's all about their proportions. It's all about the way that car sits with the big long hood and just the elegant, simple lines that go across it. They're just timeless.
When you build something in clay, you get this full-size model, and you get the whole feeling of how the car looks and what it's going to express that you just don't get if you design the car solely on a computer screen.
We're looking for the most beautiful proportion all the time. We use golden section naturally as designers to create form, to create shape.
The golden section, or golden ratio, is a mathematical formula used to describe beauty. It was first discovered by the ancient Greeks over 2,500 years ago. It's a theorem that tries to find logic in beauty. Yet even today, it still affects the most exotic and modern supercars in the world.
It's a rule and a principle, a mathematical rule. It comes from nature. The Nautilus shell, for instance, everything within the Nautilus shell fits perfectly within that golden section, the golden triangle, as it were.
The golden rule might come from the old world, but the design team's use is uniquely contemporary and uniquely British.
The Brits are known for understated design. They bring cues from the 60s and 70s, and they brought that all the way into today. It's not an easy thing to define necessarily, but it's an elegant, classy design. It's not vulgar in any way. There's no huge affectations.
Aston Martin means these sporty grand touring cars. Cars that you want to drive across continental Europe in 10 minutes with your foot on the floor. They're incredibly powerful, but they're also incredibly comfortable and beautiful. It's a car to be seen in.
It's the understated gentleman's Ferrari.
Marek and his team blend that open appeal with a modern style.
That becomes the battle to make sure we get the best looking car that is going to be timeless design, a future classic. So it's really about making sure everyone understands the direction and the goal.
That goal is a contemporary reinterpretation of an old American hot rodder's trick. Take the biggest, heaviest, and most powerful engine and drop it into the lightest chassis. A 565 horsepower engine called the AM28.
And that's just the ancient hot rodder's recipe for making an awesome sports car.
Everybody loves a good stick the biggest motor in the smallest car you got. And sometimes it can be fun, sometimes it can be a little bit too much. In the case of the Aston, it's probably both.
Engineers predict that the 4 extra cylinders will propel the machine to a 329 km/h top speed. There's only one problem. The engine doesn't actually fit. In an ever-changing automotive landscape, Aston Martin looks to turn heads with a new hot rod-inspired supercar.
Since Aston Martin doesn't have a big car maker to support them, they have to do everything on their own.
It takes so much money to develop a new car. And if you don't sell 4 trillion of them, you can't recoup that development cost.
They can't afford to make any big mistakes because that could cost the company everything.
If Aston misses on anything, I think we're going to have to say goodbye to them.
So how does an independent car maker expect to compete with some of the largest car companies in the world? The answer lies in the quiet green hills of Warwickshire, England. Welcome to Gaydon, the beating heart of Aston Martin since 2003. It's one of the most technologically advanced automotive factories in the world.
It's a facility where people are manufacturing these beautiful sports cars with great passion.
54 acres of space-age technology paired with British refinement.
It's quiet, it's clean, it's very, very high-tech.
Every phase, from design to production, takes place on a single campus. It's here that engineers and designers struggle to solve the critical problems facing the project.
The front end of the car was designed around a V8 engine, so the first challenge is actually getting the large engine to fit in the space.
Engineers digitally comb over every single millimeter of the engine bay to find a solution.
The big challenges were the packaging of an engine which had 4 more cylinders than the previous engine. Just to give you an example of that, that's about that much longer, within the same wheelbase.
When engineers first digitally drop the V12 engine into the V8 chassis, they immediately have a problem.
So you can start to see some of the pinch points here, and just here on the front of the engine, as the bonnet dives over, we're in a tight pinch point here.
A pinch point is where 2 pieces don't fit correctly. Getting the engine to fit comes down to just 12.5 millimeters. a little less than the height of 2 iPhones stacked on top of each other.
Usually we would look for 25 millimeters, but in some cases we've halved that.
In the end, 12.5 millimeters are the key to bringing a new machine to life.
The pressure on Aston must be enormous because they have such limited resources and they have to keep coming out with different things.
Any failure could mean the end of the marque's illustrious legacy.
One of the challenges that we believe we always take on here is doing the impossible.
With their reputation hanging in the balance, and perhaps their solvency, the Aston Martin design team boldly surges forward.
As a small independent car company, they're a lot more agile. They can do fun things, they can do crazy things like that car. Things that wouldn't get through a regular car company's processes.
That's something that we would say, well, of course we can do it. We don't have to follow this rule, we don't have to think in this way, and we can make it work.
It's a unique form of bravado from a company that's no longer willing to keep a stiff upper lip.
But if they built like some sort of car that wasn't really an Aston Martin and, you know, they spent a lot of money on it and it didn't sell, that could kill the company.
This small independent is about to go toe-to-toe with some of the most powerful companies in the world. But only if it can learn to control something that you can't actually see. In the world of extreme supercars, powerful engines always get the glory. But it's the air surrounding them that provides the greatness.
Literally, as you shoehorn your foot into a very tight shoe, that's what we try to do with the V12 Vantage S engine.
Shoehorning the larger V12 into the chassis is just the first step. The real key is to manage the airflow around and inside the machine itself.
And we've got a lot to come through the engine bay, what we're going to do with all that air that's going into the front of the car.
Controlling the air creates 3 distinct challenges. First, the machine needs to be tuned so that it's stable at high speed.
At 200 miles an hour, an airplane can take off. At 200 miles an hour, a car can take off too. So you want to make sure that the aero package is right so that the car stays on the road.
But the car also needs to cut through the air easily. That requires creating the least amount of drag possible. Drag is a type of air resistance.
Drag, effectively, is the force you've got to how hard you've got to work to push the air out of the way.
Tuning the machine to be stable and reducing the drag proved to be easy compared to cooling the machine.
We've got a more powerful engine and it fills the engine bay a lot more.
As soon as we found out we were going to put up a V12 in this car, first thing for me was, what we're going to do with all that heat.
A team of aerodynamicists use a sophisticated 3-dimensional model made up of over 60 million cells to find the best way to move the air. The first step is to map what you can't see.
Red is good, and that means there's lots of energy left in the air. So this is us before we get to the car. And as the car passes through the air, that energy is transformed into heat rejection.
Air particles pass through the car in just 50 milliseconds.
In that 50 milliseconds worth of time, that air has to cool the brakes. It has to travel round the car without causing too much drag. And it also has to make sure that the car is absolutely planted at speed.
The air loses half its energy before it even hits the engine.
Within the space of about 100 millimeters, or the length of your forearm, there's slowed down from 200 miles an hour down to 100 miles per hour.
When the machine is moving, the air slows down quickly. But when the machine is stopped, getting the hot air out is even trickier. To do that, they tune the louvers on the hood.
Aerodynamics is kind of seen as being high speed, but actually delivers more at low speed. What we've got here is, this is a prototype bonnet. We've got this bonnet here, which has all got these extra louvers in, which we derive from motorsports experience. These parts actually in here, they can be changed. If I flip it over, you can see each one of them is tunable. So we tuned these to get the maximum airflow through them. Whilst it's running at high speed, so it draws more air out, that gives you kind of a better head start. If you keep the engine cool in the first place, you haven't got such a mountain to climb when you actually stop. But also, when the car stops, it allows all that heat that would build up inside the engine bay to come out.
At speed, managing the airflow is critical and complicated. Because air travels through components at pressures 1,000 times greater than the capacity of the human lung, how the team channels it throughout the vehicle makes all the difference.
We've got to kind of separate that out between how much goes into the engine to give us the extra power to reach the top speed, how much we need to obviously cool the engine. You're going to heat the brakes up to 700 degrees. We've got to have airflow pumping into those wheel arches to cool that down. So it's this finite balance of trying to achieve all those things with all the air around the car.
From an engineering standpoint, the V12 Vantage S is an engine-heavy dragster, just like the 1950s American hot rods that inspired it.
V12 Vantage is a real engineer's car. There's a bit of hot rod in there because it's the big engine in the smaller car.
One of the keys to a great hot rod is how it sounds. Inside a hidden garage, off limits to the public, engineers use a high-tech camera system with 32 microphones to visually chart the engine's audio signals. This lets the team precisely tune which sounds occupants hear and which they don't. The camera records data at 96,000 times per second. They then use a color map to identify the noise characteristics, with purple being the loudest sound. Finally, they combine the camera imagery with the audio data to pinpoint exactly where the sounds originate, sounds which help intensify Aston's unique exhaust note.
Absolutely beautiful noise that you only get from a 12-cylinder engine. I mean, they don't sound like anything else.
The problem is, Aston Martin doesn't make hot rods. They make exquisite supercars laced with sophistication. Today's global buyers expect more than just a big engine.
Anybody can make a fast car these days. What Aston really needs to do is appeal to the emotional side.
There's an understated elegance about an Aston Martin. It's maybe more about wearing the label on the inside than the label on the outside.
It is the gentleman supercar. First of all, they look the part, they sound the part. They're a little bit more restrained, but they are no less serious when it comes to performance.
So how do you transform a hot rod into an Aston Martin?
And there were some really long nights on that of saying, how do we make this work? How do we get that mix of refinement, but with a little bit of rawness into there?
A fateful discussion over a cup of coffee has led Aston Martin to put their largest engine into their smallest chassis. The question now is, how do they transform this modern hot rod into a refined luxury vehicle?
It's always about pushing the technology, pushing the innovation of the material.
High-tech and handmade are two staples at the Gaydon factory, where over 200 man-hours go into the assembly of just one Vantage. The process begins in the trim department.
This is Gaydon Trim Shop. This is where all the leather panels are all stitched together.
Each Vantage interior utilizes 6 full hides of leather.
These are Alcantara panels. These have just come from the sewing area. The parts are now being laid out into the spray booths, and the adhesive is now being applied.
Once the glue is sprayed, the leather workers have just 4 minutes to apply it to the plastic.
Now the adhesive is no longer wet, it's just tacky. Once you put the two parts together, it forms a permanent bond. There are 50 trimmers, and they'll make over 300 parts a day.
It takes roughly 50 hours to make all the interior trim pieces for just one Vantage. And the most important tool has a name that harkens back to Stonehenge.
There is one major tool, that tool is called a bone, and that is the one that pretty much does it all.
The leather parts might be made very traditionally, but if you order a bespoke Vantage, the stitching is absolutely high-tech.
This is the quilting operations area. This is where our bespoke quilting is produced.
The quilting machine looks fast. It had better be. There's more than 1 million stitches in a Vantage. While old-world artisans spend 2 days crafting the interior, it takes just half as long to build the space frame. Each panel or casting arrives at the factory having already been superformed, a process where metal is heated to extreme temperatures before being stamped into a final shape. Robots supply oxy-adhesive. The adhesive is both more accurate and stronger than a traditional weld. The entire space frame is cured in an oven at 185 degrees centigrade for over 30 minutes. A slow burn for a fast machine. Now the chassis is ready to receive its bodywork. Then they fit the doors, front quarter panels, and bonnet. Each body is inspected by hand, then it's time for a splash of English colour.
We're now at the start of the Aston Martin paint process. As you can see, we've got the car delivered into paint. Quite a different car as to what you're going to see at the end of the process.
Only at Aston Martin, that colourful demeanour is just as special as the machine itself.
The full paint process takes on average 50 hours per car.
Unlike high-volume factories where cars are painted in batches of the same colours, at Gaydon, each vehicle is painted individually. It's not efficient, but it is effective, even though they actually use very little paint.
120 microns of paint will be added to the car, of which we will remove 30 microns in our polish process to make it a mirror glass finish. So in theory, you have got something the thickness of that on the car finished gloss level.
That shine starts with a single coat of primer. Now it's ready for the prep line.
The idea of the prep line is we look for any imperfection before base coat is applied. We have a very big ethos with prep work.
Once the car is primed and prepped, it's ready for paint.
This car will have base coat applied in the booth there. It will then be dried for 20 minutes, moved into a flash-off oven, and then we apply the clear coat by hand.
Each Vantage then receives 2 layers of paint and 2 layers of clear coat. Some done by robots, some done by hand.
Paint shop has a degree of automation. We've got some robots in there for spraying, and lots of hand finishing to get the depth of paint finish onto the car.
The machine is ready to be polished.
Very different to high volume, run-of-the-mill factories. You will not get this process.
Once painted, it's time to put the machine together. In the final assembly hall, where it takes 42 stations to build a Vantage.
We're currently on the first part of the assembly line, trim 1. Throughout the rest of this line, we're fitting some of the key parts that your average driver doesn't really think about on a day-to-day basis.
It's a very classic way to build a supercar. And the only way to build an Aston Martin.
Superficially, it can look very similar to a conventional car production process. It's still very much a craft-based production system.
Rear deck lids are pre-assembled and then installed. Finally, the car is ready for its massive handcrafted instrument panel.
The technicians will use this big device here, this assister, because it's a very heavy part is the IP, then pick it up and mount it to the vehicle.
While the majority of the work on the line is done by hand, the newest addition to Gaydon is completely automated. The robot places adhesive on the edge of the windscreen and is far more precise than a human.
Well, it's the first part of automated equipment that we have on this line, and we've done it solely to help us improve quality.
Quality that meets performance on an adjoining sub-assembly line, where the powertrain begins to come to life with the naturally aspirated V12 engine.
We're now in the powertrain sub-assembly area. Here you can see one of the V12 engines. And what we do is we take the engine in a pallet, we load it up like this, and then we carry it over to the first part of the assembly process. Where we assemble the engine to the torque tube, and we then have the gearbox at the back of the vehicle.
They continue to build up the drivetrain by bolting on the transmission, followed by the catalytic converters, then the heat shield, rear disc brakes and suspension.
So we fix what we call the front corner units. So that's the assembly of the brake disc, the brake parts and the suspension parts, before we then marry it up to the car.
The front suspension is built as a separate sub-assembly, where they bolt on the 398mm carbon ceramic disc brakes. Once it's completed, it's joined to the rest of the drivetrain.
We need to fit the radiator on the front of the engine unit. By having the engine, torque tube and gearbox arrangement, we can get the optimum weight distribution in the car, which is so important for the handling of the vehicle.
85% of the weight distribution sits between the wheels, helping agility on a track. The 7-speed transmission launches the machine from 0 to 100 kilometers an hour in under 4 seconds. Now it will take the team at Gaydon 40 minutes to install the single most important piece of the Vantage. It's taken over 100 man-hours for the fastest, production-based Aston Martin ever to get to the single most important station on the line.
The bit that I like the best is what we call the marriage station, where we take the whole of the driveline of the car and we marry that up into the body structure of the car.
Even though the machine is now married, it's not quite ready for a honeymoon. The Vantage still needs some key bits of kit, like exhaust pipes, the front bumper,
There is no line that intersects between the lamp and the fender. It's embedded like a jewel set in a ring.
Jewelry that takes a surprisingly long time to install. It takes 15 minutes to set just one headlight. Then they place the taillights.
Clearly these cars are going to need some wheels. And after that, we build up the interior trim of the vehicle.
The Vantage is ready to move to the very last line.
And trim 3 is around fitting all the parts of the car that you touch and you feel when you're inside the car.
Front seats come to the line fully assembled from the trim shop. Then the hand-sewn steering wheel. Doors are brought to the line and carefully installed.
Once we've fitted the doors, the car will complete the last couple of stations on the assembly process.
As the car nears the end of the line, there's one more key step. The famed Aston Martin wing. So precious that they keep it locked up until it's ready to be installed.
This is the only badge or wing left in the automotive industry made by a jeweler. So we know this is very special.
Before a completed Aston Martin can leave the factory, it must first take a few laps around the test track.
This is part of the off-tracks facility. This is our new rolling road. It's going to get up to about 70 or 80 miles an hour.
Off-tracks is where each vehicle is tested to meet quality control standards like wind noise and waterproofing.
By doing these test processes in a controlled environment, we can make sure we do it the same every time.
Then building a Vantage literally hits a bump in the road. In the hydropulse area, they simulate road inputs using hydraulic actuators to find squeaks and rattles. The very last test is a final inspection.
Well, we spend about 20 hours specifically checking over the car as it's produced and at the very end of line to make sure it's absolutely perfect before we ship it on to a customer.
It's taken almost 10 days of assembly to complete the V12 Vantage S. The fastest production-based Aston Martin ever built. And a bold gambit by one of the only remaining independent car makers in the world. In a hyper-competitive automotive world, Aston Martin must do a lot with a little in order to stay relevant.
Building a car on your own is expensive. If they build the wrong car that doesn't sell, they're a company that's going to be in a lot of trouble.
Now, after months of sketches, sculpting, and intricate assembly, a risky idea is finally ready to enter the real world.
The first thing you do when you get into any Aston Martin is go, how do I start it? You have this key that is made out of crystal. And you put it in a slot in the dash, and you press it in, hold it, and then the engine starts. Aston calls it the emotional control unit. You could look at it as gimmicky, but when it's that beautiful, it doesn't matter. It's a little bit of theater, but my God, if you're gonna do theater, you might as well do it on a car that looks like that.
You fire the car up and it just goes, and it just wakes up like it's been in some deep slumber and it's really pissed off that you just woke it up. And then you go out driving it and more of that happens.
It's a decidedly angry form of British sophistication.
Astons are British Camaros. They're loud, they're brash, they're rough. What Aston's done brilliantly over the years is taking a small number of ingredients and making a lot of different dishes with them. This V12, for example, dates back to the year of the flood. It's really old.
What makes the AM28 so unique isn't new technology, but rather old technology at its best.
Thank God it's not a turbo. Downsizing an engine and putting turbos on it makes easy power, but I call it cheating. It's just too easy. There is a charm and a personality that normally aspirated engines have. And that's something we're missing out on.
To have a naturally aspirated engine these days is actually becoming kind of rare. It's old technology, but there's something kind of special about it.
It's an angry, angry car, and it's really visceral and really powerful. It really speaks to you in that way.
And every time Aston comes out with a new version of this engine, you think, oh, they're beating this dead horse. Except the horse ain't dead. This horse is faster than the previous one. It sounds better. It's more powerful. It responds better.
The V12 Vantage S is the most mainstream Aston to ever crack the 330 km/h barrier.
We sort of dialed a few things up, maybe from 10 to 11 in some cases, and we put more power and performance into the car.
205 miles an hour is incredible. It's a completely different world.
This is the highest performance version of a high performance version of a high performance version of the Vantage. Every time you step up the ladder, you get a little bit more jewelry and spoilers and stuff like that.
It's an extreme way of building a car, and that's not for everybody. You throw fuel economy out the window, you throw everything that most people really care about on a daily basis, you throw that out the window and you build an extreme car that's loud and powerful and raucous and fast.
An extreme car with extreme performance.
If you take one drive in one of these cars, you realize that the people who are working behind the scenes at Aston are clearly sports car guys.
Sports car guys who continue to battle for their very survival by doing the only thing they know how to do, build beautifully exotic supercars.
At the end of the day, no matter what I drive, at whatever speed, on whatever track, I always come away from the Aston thinking, God, that's more fun than anything else.
I pinch myself every single day still after almost 9 years that this is not a job, it's a vocation, it's something which is very hard to describe the feeling. Just the sensation of what you're actually achieving in terms of the heritage, the future of the brand of Aston Martin.
They are the most communicative sports cars on the market now, and they show no signs of moving anywhere away from that. If that means there's no Aston in 20 years, hey, at least we had some of the best cars now.
For generations, Bentley has ruled the world of luxury saloons by being bigger, faster, and louder than the competition.
It's beautiful, it's luxurious, it's fast, and it's expensive. That's rarefied air.
For over a decade, the Continental GT has been the brand's signature machine. Once it was the fastest four-seat production car in the world, hitting a top speed of 318 kilometers an hour. Combining competition-level performance with luxury worthy of royalty.
The proudest achievement was producing a car for the Queen of England in the same year as winning Le Mans.
However, the platform has aged.
The car's had an extremely long shelf life. It's ancient.
Competitors are nipping at the company's heels.
The world is catching up quickly. If Bentley doesn't keep innovating, then they'll have a problem.
The brand's answer isn't to reinvent an icon, but to refine it, creating their most powerful and fuel-efficient machine ever, the Continental GT V8S. The Continental GT V8S is the latest Bentley to wear a red flying B. A subtle insignia that hides in plain sight. But the red badge means only one thing: speed. With 521 horsepower on tap, the GT V8S is the most powerful entry-level variant of a machine that's over a decade old. In 2003, the Continental GT emerged as the ultimate dual-threat supercar, exuding high-end luxury and total performance.
It was a real bold move to decide to go for luxury coupe for the brand, to set up the start of the brand, and the reset, the Bentley 2.0 phase of the brand.
Bentley came into this segment, there was really nothing that competed against the Continental GT. It sort of opened up a new segment up there between $150,000 and $200,000 that ruled for many, many years.
Single-handedly, the GT resuscitates the grand touring genre.
It was about creating a really special coupe, 2+2 seater, which was combining performance and incredible driving experience.
It was really a coming together of two worlds, the blending of the luxury world with the performance world. It was a real breakthrough car for us.
Almost overnight, the machine becomes an automotive icon.
When it entered the market in 2003, it changed the perception of the whole brand completely.
Part supercar and part super saloon, the machine quickly increases sales fivefold.
The change was dramatic from where it was, producing just around 2,000 cars per annum to producing just over 10,000 cars.
Continental was a play for volume by Bentley. This was a car that was more affordable and also an everyday livable car.
The GT's success traces its roots back to a formula that's nearly 100 years old.
That special combination of the performance, luxury, and practicality, that's what makes that Bentley GT to an icon.
A mantra where bigger is always better. It's an ideology that harkens back to W.O. Bentley, the man who founds the company in 1919.
W.O. Bentley created relatively big cars. He was of the opinion that if the car is not fast enough, I have to put a bigger engine in.
When the brand reboots in 2003, the team doesn't start with the engine, but rather the shape of the car itself.
It started with a blank sheet of paper, believe it or not. The styling of the car certainly dictated quite a small engine bay, so we had to come up with an engine that would package in that tight engine bay and produce the power and torque that one would expect from a Bentley.
Packaging concerns lead the team to create a unique W12 engine.
The W12 is an interesting engine, and its layout is not really shared by anything else. The W12 is two VR6 engines, which are staggered. When you combine two of them is 4 rows of cylinders. That's the W12.
But age has a way of catching up with beauty, no matter how powerful it is.
It's not a particularly efficient design. It doesn't fit into the modern world in the way that some smaller engines do because it doesn't get the greatest fuel economy.
The once emboldened Continental is now on borrowed time.
When we entered the market with the Continental GT, it was unique. Today, there are probably 10 or 20 competitors.
Younger, lighter, and nimbler challengers have started to steal its thunder. For years, Rolls-Royce was the brand's main rival, but now a variety of marques have Bentley in their crosshairs.
So there's no time for us to sit still.
The high-end, posh society that the original machine targeted has changed.
Consumers can be very fickle. After a while, if something stops being cool, they're going to move on to the next thing.
Rising fuel costs have also challenged the very foundation of the brand.
They're in a very difficult position that they've been very successful in this car, and there's a lot of people who want this car the way it is, but they still also have to keep it modern.
In order to remain at the top of the GT category, Bentley has to do two contradictory things at the same time: increase power and slim its flagship down.
Bentleys have never been lightweight. They've never been small cars. They weigh as much as a lot of SUVs, but they make up for that with a lot of power.
Reworking the Bentley archetype is no small feat.
For a brand like Bentley, very important to understand how to transfer this rich history into today.
Now it's up to Luc Donkervalk, head of design, to bring the classic Conti shape into the modern age.
It's an industrial process relying on an artistic communication language, which is drawing.
To get modern, the team goes back in time. They start the new model's revision by sketching lines on paper.
It's really important is what we call the power line and the haunch. Those two lines are the DNA of the brand, and they are really present in different orchestration.
The brand's strong history is a blessing and a curse.
We don't want to make a retro car, but we want to anchor it in the past, in the traditions of the company.
Designers labor to push the edge.
This wow effect you get when you see that car first time is coming from the styling.
Tradition takes a dramatic sidestep towards new tech inside the Bentley Visualization Suite. A state-of-the-art facility where a simple sketch on a napkin can become a life-sized, three-dimensional model. Exterior designer Gareth Thomas is tasked with tweaking the car's classic lines.
Once we've developed the sketch, we'll work with the CAD modelers, and that's where the exciting bit begins, really.
His team sculpts the next-generation Bentley using next-generation technology.
Here you can see the CAD one-to-one scale of the Continental GT.
Within this virtual photorealistic environment, parts can be tested for both look and functionality.
It's really important that what we're designing isn't just fantasy. The CAD data is a really important, crucial part of the design process. It's from this CAD data that the actual parts are manufactured.
Designers can test each particular piece for size, shape, and surface quality. It's like a video game for creativity. The new headlamps become one of the key parts to move the machine into the modern era.
The challenge is always how to do this in a modern interpretation and to keep the design fresh. The development of LED technology is certainly allowing us to do that.
The LED lights and glass covers are created with a click of the mouse. Beyond the face, the body lines are virtually refined as well.
The reflections is how you read the surfaces of the car itself.
Reflections are key to all great supercars. But Bentley's sense of time is based on a classical philosophy.
The shape is orchestrated by those really sharp and precise lines. There's a rhythm, like in an orchestra, where you have one instrument after the other. So you have the violin stopping, and then you have the other instrument that is basically starting, picking up in a rhythm. This is orchestrated by volumes, by concave and convex surfaces, which gives this richness of the form.
By utilizing the latest technology, designers have modified the classic look of a Bentley. Nearly 100 years ago, in the British town of Cricklewood in northwest London, a railway engineer makes a fateful decision to build engine parts out of aluminium instead of cast iron. His name? W.O. Bentley. A man notorious for building the biggest engines around and the most efficient.
W.O. Bentley in 1919 wasn't all about just big cubic capacity. He was all about technology and efficiency.
W.O.'s early engines offer cutting-edge technology. His power plants feature overhead cams and twin carburetors.
It was more about torque rather than big displacement.
W.O.'s genius starts with engineering, but it crosses the finish line thanks to promotion. He realizes it isn't the power of his pistons that attracts buyers, but whether or not they win on the racetrack.
In the late 20s, a group of rich Brits called the Bentley Boys would take their giant, imposing, massive Bentleys to the 24-hour Le Mans race in France and race their cars and party, and it was a whole lifestyle thing, and they would win.
5 Le Mans victories later, Bentley Motors is world-renowned for handcrafting luxurious high-performance machines that win. In 2003, Bentley introduces the reborn Continental with a new W12 power plant. It wins critical acclaim, but time moves fast. Even faster than a Continental. What was once deemed an exceptional piece of engineering is now a liability.
The Continental had always been built on the W12, but obviously with fuel efficiency and regulations, we needed to downsize.
Brian Gush, the current director of motorsport, is one of the key engineering members tasked with finding a more environmentally friendly solution.
We had to produce an engine that was worthy of being called a Bentley engine, that provided that effortless torque.
Gush and his team turn their attention to the smaller twin-turbo V8.
The 4-litre twin-turbo V8 gives us a similar feeling with a lot less capacity.
But first, the new V8 sucks down fuel at an alarming rate. So engineers turn to a new technology.
Using cylinder deactivation, dropping onto 4 cylinders enabled us to drop the fuel consumption.
Disengaging the cylinders shuts down half of the engine during moments of low demand, turning a V8 into a V4.
It's part of modern reality that all car companies need to consider smaller models, smaller engines, more fuel-efficient vehicles.
It's got decent fuel economy for something this big and this heavy and this powerful.
The new V8 engine is far more fuel-efficient than its predecessor. But that doesn't help the Continental save weight. And the heavier a machine is, the harder it is to stop.
An equal match for the Bentley's engines are its brakes. It's got huge, huge carbon ceramic rotors. They're basically as big as an economy car's entire wheel.
The Conti needs large brakes because the machine deals with a tremendous amount of energy during heavy braking. Automotive brake systems transform the car's movement or kinetic energy into heat. At 100 kilometers an hour, a maximum stop for a 1,600 kilogram vehicle generates enough electricity to keep a 100-watt light bulb lit for an hour and a half. The Continental GT weighs over 2,250 kilograms.
From our top speed to standstill, the brakes have to deal with 10 megajoules of energy.
10 megajoules is enough power to keep an average family home going for 6 hours.
These massive, massive carbon ceramic brakes that you can just dump a ton of speed into them. And they're unfazed by the fact that the car weighs 5,000 plus pounds.
Largest disc brakes on a passenger car in the world. Well, that's another unique Bentley development which we're particularly proud of.
At 420 millimeters, each carbon ceramic disc brake uses 8 piston calipers and is the size of a deep dish pizza.
If you go fast, you've got to stop fast.
While torque-fueled performance has been a Bentley trait for nearly 100 years, if it wasn't for the craftsmanship behind the badge, there'd be just another sports car.
For a brand like Bentley, with this rich history of nearly now 100 years, it is very important to understand what are our DNA.
Today, that DNA is found here, inside the Bentley factory in Crewe, England. Built for World War II, the factory is entrenched in the history of British motoring and engineering.
Nothing would prepare you for working in Bentley. The processes, the materials we deal with are completely different to anywhere else.
This is where the brand's coach-building past combines with modern technologies to create the new Continental GT.
Continental takes about 120 hours to build. It feels very high, particularly from the car industry, but the difference here is at Bentley we make everything.
Unlike most car factories, at Crewe, there are individual shops devoted specifically to wood, leather, and the famed Bentley power plant.
It's about the art of transforming those materials and putting them together into a car.
Keeping all those substances in check starts inside a unique laboratory run by Helen Davok. She and her team use a variety of machines to test each material to its absolute limit.
Our job, quite simply, is to make the best products even better than they already are.
Materials which range from man-made metals and glass compounds to the tactile parts of the interior.
Wood and leather are natural products, and maybe many people don't realise the technology that goes into them.
Everything in the vehicle, from the steering wheel to the iPod drawer, is built for maximum durability.
On the outside, it simply looks like a piece of wood, but actually, when you look at the science of it, it's a multiple layer construction.
There's only so much real-world testing that can happen in a lab. So the team consistently tests materials in the world's harshest environments.
We take whole Bentleys and we leave them in the desert for literally years, and all they do is sit in the hottest environments and bake. We're expecting this wood, a natural product, to last that kind of environment.
High-tech science that begins in a very old-school wood shop, where 167 artisans craft some of the finest pieces of wood in the world.
Currently, we're taking about the top 10%, between 10 and 20% of the top veneers across the world.
The veneers are made from wood that is sourced around the globe. There are 14 types of wood and 9 veneer options. Each layer must first be bolt cut to size before it can be perfectly matched.
A lot of the parts we use at Bentley actually require mirror matching. This is where we'll edge and joint one side of the veneer to create a mirror image. We'll flip the pieces over, create a nice mirror image into the center of the part when it's die pressed onto the part.
Next, the wood is coated with a strong adhesive before being pressed onto the parts. It takes 7 hours to make one piece, and there can be up to 33 wooden pieces in each Continental.
Extreme heat and extreme pressure for about 5 to 10 minutes actually allows the veneer to permanently bond to the substrate.
The pieces are sanded lightly to remove any impurities, then they're ready for lacquering.
What it actually gets is 5 layers of polyester lacquer. We'll actually take the surface, Similar to the sanding stages, we'll use grades of paper. Gives it this very kind of dull, matted finish.
After the lacquer is applied, the pieces are polished.
We'll take it onto our high-powered speed polishing mops, shine it up using a series of wax movement techniques, which actually gets any little scratches or ripples out.
The final piece is more mirror than wood. However, the treatment isn't only for appearances. Each coat creates a microscopic protective barrier against heat and corrosion. While some pieces are pushed to their limits outside, others are heated to their core right inside the laboratory.
So what we've got here is a thermal cycling chamber. This machine goes perhaps twice as hot as the hottest day you would get in the desert to as cold as the coldest parts of Russia.
Leather elements are verified for wear resistance.
What we're interested in, obviously, with this machine is wear resistance. You'd expect more than 20,000 in and outs of a car would be something nowadays, say, that this would ensure.
Metals are tested to remain durable and aesthetically pleasing.
This is a salt spray cabinet, which we use to accelerate corrosion environments.
Each wheel is drenched in a copper-accelerated salt spray with an acidic pH of 3.2 for several hours. That's 80% of the acidity in a single can of soda.
What's really important for us is that the Bentley that leaves the factory today looks as good for our customers with many years to come. It's an extremely harsh environment that we expect all of our wheels to perform to. Quite frankly, if they don't meet that requirements, they won't be used on a Bentley.
Once materials have been tested and approved, it's time to put them into production. Inside a factory that not only creates cutting-edge machines, 8 years before Bentleys were manufactured in Crewe, these brick walls were constructed to harbour the ferocious thunder of 27-litre fighter plane engines.
Crewe was built in 1938 as a factory to build 12-cylinder Merlin engines to power the Spitfire and Lancaster planes.
The Spitfire was one of the fastest and most victorious British aeroplanes in World War II. It's a heritage valued by the craftsmen who today build more W12 engines than any factory in the world. Since 1946, the brand has built over 66,000 12-cylinder engines.
Kept the building the same and just renewed the technology that's inside them.
Merlin 12-cylinder aircraft engines produced over 1,000 horsepower. Not a far cry from today's Bentley 12-cylinder engine, which musters up an airworthy 616 horsepower.
We build more 12-cylinder engines than all other manufacturers put together.
The engine block begins its journey to the line on a tool slightly more sophisticated than the ones used in the 1930s.
So the first job we do is we take the engine out of the stillage, lift it across onto one of these machines here.
The machine is an AGV, or Automated Guided Vehicle, and it allows engine builders to move the massive blocks with ease.
We then separate the bed plate from the main crankcase, and we fit a crankshaft. This is the first stage which we give an engine its main identity.
Each step is done by hand.
So the next part of building a Bentley engine, we rotate the engine around and we apply oil. This is the first time oil touches the engine.
Now the engine's ready for its pistons.
We then automatically build up the pistons. So each engine has 12 pistons, 12 conrods, and also 24 different bearings. So all of those are built automatically, as you can see in the machine there.
The machine connects the piston head to the conrod far more precisely than a human.
When they finish the process, this will have a complete set of pistons. One of the main difference, as you can see, if you look on the top of one of the pistons, it's not flat. What it means is that we can get the best compression ratio on the engine itself.
The higher the compression ratio, the better the fuel economy. Once the pistons are done being fit by hand, the engine goes through an automated sealant process.
And we do that for a variety of reasons. One's volume, and also for quality. It also gives us a very consistent product every single time. The process we've got here is where we set the timing. So what we have, all the camshafts on the top of the heads, and we have these devices on the end that allow us to change the characteristics and the amount of torque that the engine's producing at any one time.
Timing is important for the engines and the line itself. There are 21 stations installing nearly 700 parts inside of each W12 power plant. Depending on demand, nearly 250 engines can come off the line in a single week.
Every 16 minutes, we have a brand new engine come to the start of the line, and a completely finished engine comes off the end of the line as well.
That engine is the most powerful W12 in the automotive world. But before the engine is completed, it must be engraved.
So this stage here, this robot will give the engine its unique engine number. So that will go with a vehicle identification number and make up the history for the car. The most challenging station on the line is this process here. So this is fitting the loom. The loom's always particularly difficult to fit. It requires the operator to know exactly where each and every single connector is going to go to on the engine.
The loom looks like one piece, but it's actually comprised of dozens of wires that allow the high-tech engine to communicate with the cutting-edge electronics system. Installing it is a time-tested process, created by workers who are sometimes generations in the making.
We've been building engines here now for 75 years, so it's really not that uncommon to see fathers, sons, and multi-generations coming through and learning how to build them. Every single engine we produce, we bring it into one of these test cells, and then we run it for 21 minutes to check the power, check there's no leaks, make sure the engine is perfect every time.
Hot testing an engine like this is the equivalent of a 16-kilometer drive.
We value the fact that we can test every single engine. We do it because every single engine we build is a supercar engine.
High performance is only part of the supercar equation.
What you'll see here at our facility is craftsmanship on a mass scale, and we've got a staggering choice of options and colours.
There are 13 standard leather options to choose from, and each one is matched by a nearly endless number of exterior colours in the Bentley paint shop.
We've got a massive colour palette. We can offer a range of around 150 colours here.
Each Bentley will be decorated with nearly 45 kilos of paint. When the body is finished being coloured, it's clear-coated and then baked. Only then can craftsmen begin to apply the classic Conti shine.
The mirror finish is what sets the Bentley apart from the rest of the manufacturers.
Craftsmen use a variety of different levels of sandpaper to remove microns of paint.
It's where we take a normal paint finish and we convert it with our process into a Bentley finish.
Great finishes are only half of the Bentley story. To stay competitive, Bentley must put greater emphasis on sub-assembly than anyone else in the business.
In the rest of the industry, about 90% of the people work on the body of the car, work on the car itself. Here at Bentley, we've got a complete shift. 80% of our people work on the parts that go into the car, rather than working on the car itself.
It takes over 700 outside contractors producing 18,000 parts from 32 countries on 6 continents to supply the Bentley factory.
It's very challenging because actually you're your own supplier. If things aren't right, we've got to put it right. And this is the area we'd start in an area like this. Thankfully, the quality levels coming out of these areas is just what we expect for a Bentley.
Beginning with the unique Bentley steering wheel.
This is Noel Thompson. Noel's one of our master craftsmen. One of the special tools that Noel uses is actually a fork, and it's a fork that gives us this very unique pitch between stitches on a steering wheel.
Each handcrafted wheel can take up to 4.5 hours to finish. And to contrast stitch the entire cabin can take over 5 hours. Part of that cabin includes handcrafted seats.
At the moment, we're in the seats technology for leather.
Seat construction is a 4-step process. Cut, sew, build, and cover.
You'll see that the inspector hide, this will be selection through the different grades of hide that we will be using for different areas of the seat.
Selecting the correct pieces for just a single set of seats can take almost 2 hours.
6 inspection tables on average per week would go through 4,000 hides.
It takes 5 hours to complete a full set of seats for each GT. Every phase is meticulously done by hand. Except for one very special station, where a robot sews 5,000 stitches to craft a single B for the headrest.
If I was going to stitch that by hand, I would say that'd take you a good week.
It's essentially what the Bentley heritage is built on. Very traditional materials, assembled in a very traditional way. It's more akin to furniture making than it is to making cars. It's much easier to use the fake stuff. It's a real challenge, particularly when it's a lot more competitive than it was, say, 30 years ago.
While the interior sub-assemblies are finished, a brand new engine is being prepped for installation. The question is whether or not it's too late for the mark. The Continental GT has been in production for over a decade. In the supercar realm, that is an eternity. Especially in a changing world where fossil fuels are on the run. Bentley's solution? Offer customers 2 engine choices. Their famed W12 and a new V8 that's more fuel efficient. Both engines enter production on the very same powertrain line.
We're in the engine preparation area. We've made these engines that you can see behind us. We've got the V8T engine and the big, powerful 6-litre W12 engine.
Technicians fit exhaust pipes, shocks, and brakes. Once prepared, the powertrain is ready to be bolted to the body.
This is where we wed the powertrain with a car. And this is really where everything starts to happen in a car plant, because this is critical.
Just 25 bolts secure the V8 into the engine bay.
When you're dealing with a high-power performance car like a Continental, this is critical. Every one of those screws has got to be to the right tightness.
Monitors record the torque and angle of each screw to ensure quality.
We won't allow any car to pass forward with a screw that isn't tightened to the correct torque.
The engine marriage is one of the key stations inside the 150,000 square meter final assembly area.
The build hall in any car plant is really the heartbeat. This is where it starts its build process. So this is its journey from being a body shell to a full car.
It takes 104 hours to build just one Continental GT.
The production line essentially is very similar to other car plants. The difficulty we've got at Bentley is we mix 3 different models together.
Assembling multiple models on one line exponentially increases the need for efficiency and organization.
You can imagine the material that goes into a 2-door coupe is very different to a convertible, which is different again to a 4-door.
They install the radiator, headlights, body panels, bumpers, and wheels. Then all the natural materials that have been painstakingly sourced and tested converge. One of the last stops is the handcrafted steering wheel.
We're on checkpoint 8. Checkpoint 8 is important in this assembly process. This is the last process before a car leaves the factory.
The latest incarnation of Bentley's signature Continental is complete. But does shaving weight and adding fuel economy make for a better Bentley? In 1950, Bentley debuted the R-Type Continental. Many regard it as one of the most elegant cars ever made. The R-Type propels the brand to the forefront of the luxury auto realm. More than half a century later, Bentley finds itself at a similar crossroads.
car industry has moved on leaps and bounds. So what we don't do is sit back on our laurels.
Bentley's solution is the brand new Continental GT V8S. A lighter, smarter, and hopefully quicker machine for the modern world.
V8s still have their own mythos. People still associate them with big power and fast cars, but they're not quite as prestigious as a 12-cylinder engine.
It's a myth born during W.O. Bentley's day, but today being answered in a very different way.
The V8 is a little less special in some people's eyes, but when you look at the power this thing makes and what it's capable of, you're not missing out on anything.
The V8S roars to the tune of 521 horsepower, and the machine offers 502 foot-pounds of torque, figures which provide the classic Bentley growl. The new twin-turbo V8 takes the GT from 0 to 100 kilometers in just over 4.5 seconds.
The funny thing about Bentleys is you get in them and you say, okay, it's 4.6 seconds to 60, that's quick. And then you realize it's like sitting in your living room and having your living room go from 0 to 60 to 4.6.
Continue to keep the pedal down and you'll reach 160 kilometers an hour in just 9.2 seconds.
They just keep going and going and going. It's not the 0 to 60, it's the 60 to 120 and the 120 to 180. They just never stop.
The machine's top speed taps out just a shade under 309 kilometers per hour.
So you have a little V8 with turbos on it, pushing something the size of a small house at 200 miles an hour or near there.
At 100 kilometers an hour, the massive 420 millimeter brakes bring the GT to a complete stop in 32 meters.
You can make a 5,000-pound car do anything you want it to do as long as you upsize all the components. Tires, suspension, and of course, brakes. Something's got to scrub all that speed off. The beauty of the Bentley brakes is that they just kind of feel normal. There's nothing really special about the way they feel, except that they stop a 5,000-pound car the way most brakes can stop a 3,000-pound car.
From inside, the V8S is all classic Bentley, from top to bottom.
There's a reason why Bentleys are very expensive, and part of that comes from the craftsmanship that goes into building those interiors.
At 157,000 euros, the GT V8S isn't for the conservative crowd. However, the price tag is justified by its rare combination of speed and luxury.
It may not be the Bentley way to do something smaller.
The change in size is something W.O. Bentley would have agreed with.
We create a good car, a fast car, and at least in terms of the GT, I think the best in its class. We stick to these basic statements of W.O. Bentley and do it in the more modern way now.
Like W.O.'s first engine, the new GT is a clever step towards a smarter future for one of the world's most renowned British icons.
As long as the downsizing happens in a way that's not offensive to Bentley's brand, hey, bring it on, especially if the cars are faster.
It's the most famous bull in the automotive world, a brand born from anger.
Ferruccio Lamborghini was pissed off.
And synonymous with high-performance exclusivity.
They've been known as the company that makes wedgie cars that go really fast in a straight line, and that's it.
For over 50 years, Lamborghini has handcrafted high-end Italian supercars.
The whole point of a Lamborghini is to look and to sound outrageous.
Their most popular model is the best-selling Italian supercar in history.
The Gallardo was the most successful Italian supercar of all time.
The Gallardo absolutely was the car that put this company on firm ground.
Now, the Gallardo needs to be replaced.
for the model comes once a decade for us. So it's a very critical time, a very demanding time.
One misstep could spell disaster for the marque.
We have only one bullet in our gun, and if we miss, then for a decade we are wiped out.
It's an Italian bullet called the Lamborghini Huracán. Aeronautically inspired silhouette blasts from 0 to 100 kilometers per hour in just 2.5 seconds. It has a top speed of 325 kilometers per hour. 1/4 the speed of sound, and the weight of an entire automotive brand hinging on its success. The Lamborghini Huracán is the newest machine from the house of the Raging Bull, one of the most famed and feared marques in the automotive world. Yet the brand owes its creation to two men and a myth. In post-war Italy, industrialist Ferruccio Lamborghini is making a fortune building tractors. It's a booming business in the agrarian region of Emilia-Romagna, a place where farming has ruled for centuries. By 1960, his company sells over 400 tractors per month. The wealthy industrialist buys a Ferrari 250 GT, but, as the legend goes, the car has a problem with its clutch.
Ferruccio Lamborghini bought a Ferrari, it broke, he went back over to Enzo, screamed at him, and said, I can build a better car. This was started in anger.
Nothing looks like a Lamborghini, nothing performs like a Lamborghini. They're a very unique brand.
Ferruccio Lamborghini immediately sets his gaze on Enzo's empire. In 1963, he purchases a large plot of land 25 kilometers from Bologna, Italy, in the town of Sant'Agata Bolognese, with only one goal: manufacturing cutting-edge Italian supercars.
Sant'Agata is a little town that you definitely never would have heard of if it weren't for the fact that there are Lamborghinis driving all up and down these roads like maniacs.
3 years later, in 1966, Ferruccio puts both Enzo and the world on notice. He introduces the Miura. The mid-engine two-seat V12-powered sports car is widely considered to be the world's first true supercar.
They were very hand-built. These were kind of craftsman pieces. You were lucky if it started, and if it didn't explode into flames, bonus.
In 1974, the brand takes the next step and reinvents the very supercar genre it helps create. Introducing an edgy, angular machine called the Countach. It lays the groundwork for all modern Lamborghinis.
The Countach was described as the holy desire to build a car with a single line, and the single line was the silhouette of this car. And we are still playing around this initial concept.
While the brilliant looks and Italian V12 engine captivate auto fans, the machines are unreliable and poorly made. For the next 35 years, the brand lists from brilliancy to bankruptcy, while at the same time crystallizing a supercar mythology.
Lamborghini, has gone through a number of owners over the years. They've had big ups and downs in their financial situation. It's been really rocky.
In 1998, Audi purchases the brand and dramatically changes its fortunes. The German automaker's first task is to re-inject life into the company.
Lamborghini probably was closer to ceasing to exist than we'd like to think.
In 2003, the masterstroke, the Gallardo. A smaller, lighter, less expensive V10-powered supercar.
The Gallardo was, let me say, it's an entry-level supercar.
The machine's lower price tag opens up new markets to the brand.
The number of people on the planet who can afford these cars is pretty small. And you do need to be careful that not everyone who lives in those neighborhoods has one.
1 year after putting the Gallardo into production, Audi taps Stefan Winkelmann to be the company's new CEO.
It was 1 year after the Gallardo was introduced. The company was smaller, we had less people.
Winkelmann's first order of business is to transform the automaker into a modern brand.
Once the Gallardo happened, Lamborghini started making real cars.
Under his watch, the company has gone from pretty dire straits to today where they're stronger than they've ever been and selling more cars than they've ever sold.
In 2002, the year before the Gallardo, the brand sells just 424 cars. After the Gallardo, they sell 1,305.
It was a starting point. We all realized it at that stage.
By 2007, the marque experiences a 467% sales increase, selling a record 2,406 machines.
This is without question the most commercially successful era of Lamborghini. They've never been as financially stable.
Financial stability keeps the brand on solid footing, but doesn't make them ordinary. In the real world, seeing a Lambo is a very rare event.
In the entire world, there's less than 50,000 Lamborghinis.
If there are 71 million cars produced in the year 2013, we had a bit more than 2,000.
In its 50-year history, the House of the Raging Bull has built close to 30,000 cars.
Not only was the Gallardo the most successful Lamborghini ever made, but in its 10-year run, it accounted for more than half of all Lamborghinis ever made.
We kept it fresh and updated almost a decade.
A decade is a very long time in the realm of the supercar, and cutting-edge tech ages.
All the company was under pressure, and there was several meetings because when you start in a new project, you try to understand what is needed.
For Lamborghini, the stakes are clear and dramatic. The Gallardo keeps the brand in business.
I imagine everyone at Lamborghini was very cautious.
If its replacement fails, it spells disaster.
With the task to be able to replace the Gallardo, but to increase the success of the car, and let's say trouble from the beginning in order to think what can be better.
Repeating the Gallardo's success is a tricky proposition. In 2010, at the tail end of a worldwide depression that sees Lamborghini's sales drop 45%, the brand decides it's time to replace an icon.
It's creating something which is state-of-the-art, and pressure maybe, but a lot of expectation. My briefing to the team in general 4 or 5 years ago was very easy.
But turning it into reality is hard, because it must equal the Gallardo's success.
We developed a car which has to have an outlook of almost another decade, so you have to think forward, and this is one of the most difficult things.
To devise a revolutionary machine, the Lamborghini team focuses on 3 levels of performance.
There are 3 points which are key. One is acceleration, the other one is top speed, and then handling. In the past, number 1 was always top speed.
For decades, top speed was a selective club. Only a few machines could crack 320 kilometers per hour. Lamborghini was one of the few.
Accelerating and having the easiness in the corners. And this is done with the power-to-weight ratio.
Finding that balance is tricky when you're a niche manufacturer.
The challenge for a small manufacturer is the amount of money and the brains you put in place.
The brand not only banks on its heritage, but also its unique Italian design aesthetic.
The people which are living here, they have a certain attitude, and Italians, they are known for style. I think that Italy, it's one of the few one which is creating those type of cars.
The process of designing the Gallardo replacement starts with a basic set of rules.
We try to give simple rules to the designers, which the first one is that the design has always to be very different, but you know that it can't be anything else than a Lamborghini. The second thing is form always follows function, so there is no things which are pimped up or made beautiful just to show something which is not functional. The third one, and our inspiration is always coming from the aeronautic industry.
This car was inspired by the stealth fighter. They loved the angles and the purpose and the look of a F-22 and the B-1 and all these really neat airplanes.
Filippo Perini is the man entrusted with bringing those stealth fighters for the road to life inside of the Lamborghini Centro Stile design studio.
This room is the place where the new Lamborghini, the idea and the concept grow up here.
Perini is one of the most outrageous automotive designers in the world.
When we stop to work, we start to speak about cars, and this is completely crazy. I think that Lamborghini is built by a man for challenge. No? It's something that we have to respect, and in the daily job, this is very tough.
For Parini, that willingness to get better starts at an early age. He pens his first car at the age of 2.
This is my mother. I never take care about stuff like this, but my mother, yes. She was really attracted by my inclination to do sketches and to send sketches to the magazines. This is a magazine that was used to show artwork made by children, and I was one of them. And this is a Lamborghini.
In 2011, Parini improves on the past when he pens the Aventador, Lamborghini's newest flagship supercar.
You can see a lot now in aeronautics that there are many planes that are not so soft. First of all, because they have to be stealth.
The styling echoes the lines of the legendary Countach, Diablo, and Murcielago, but also radically pushes the brand into a new direction.
Every bit of Italian design that's successful has a little bit of kitsch in it, too. It's a little bit too far. If you look at modern Lamborghinis, you see it's probably one step too far. But isn't that the whole point of these cars?
The design we are building is driven by the silhouette. It's this line is in the middle. In the Huracán is a single one. It's monobody.
My guys, my designers, the engineers, they want to do better. They want to at least, be a bit above what the others have done.
The process starts with an internal design competition.
When we do a competition for a new product, we have at least 2 main goals. One is to do a beautiful car, and the second is to be the people that are winning the contest. It's always very important to be present in this game and to be winner.
That contest could very well determine the survival of the brand.
It was very important for them to really get this car right.
When you're pushing the boundaries of contemporary design, getting the car right means standing up for your vision.
Probably the beauty of the design job is, let me say, 10% of the game. The rest, 90%, is to save what you have done in the beginning of the project.
Designing for the future keeps the brand relevant.
At the end, you cannot follow the trend of the market, otherwise you cannot be a winner.
That future unfolds in a very 21st century way, completely digital. In a land of hallowed artisans, Lamborghini no longer uses clay to design their cars.
It's a very traditional business to design a car. You sketch it, maybe these days you do some computer renderings, but you build a clay model and you shape it by hand and you really make this so you can stand back and look at it. Lamborghini doesn't do this anymore. They design the entire car on a computer.
It's very, very normal for me now to judge a new design in a monitor of 21 inches. It doesn't matter. And after we print the model, it doesn't matter the scale.
It's an incredible process, and it gives them a lot of freedom to make little changes, and they can do it immediately.
This is the process, because it's much more lean, it's much more driven by desire. Behind a monitor, there is always a designer. If you don't switch on a computer, it's doing nothing. This process is driven by the brain of a man.
The machine is not only made by man, but lusted after too.
The sex appeal comes from different, no, we cannot say, it's porn. It's not only sex, it's beautiful.
That beauty starts inside one of the most revered supercar factories in the world.
Antagliata is the hometown of Lamborghini, and for us it's special because every brand needs roots.
Arriving at the Lamborghini factory for the first time is really a neat experience. You're driving and you're passing all these farms and there's nothing, and then you come into this little town, and then here's the Lamborghini factory. And if you get back into the factory itself, it's still the factory that it was 60 years ago. It's still the same building. They've added more buildings, but it's still there.
The factory is located in the heart of Italy's Emilia-Romagna region, otherwise known to automotive fans as La Terra dei Motori.
Emilia-Romagna, it's called also La Terra dei Motori, so it's something that a lot of super sports car brands are here.
In this area, there is a kind of Bermuda Triangle of performances. If you think about Ducati, Ferrari, Pagani, there is a concentration of needing horsepower. I don't know why there are so many companies, so many car designers, so many car fans. I have some friends here that they cannot speak about normal, they are only speaking about car.
That speed comes together on hallowed supercar ground. Today's Lamborghinis are assembled in the very same building that Ferruccio used in the 1960s.
It's been heavily modernized. It's clean and well lit and spacious. It's not, a little dusty old shop anymore. It's a fully modern factory.
That factory 20 years ago didn't look as organized as it does now. It was wires everywhere, people tripping over stuff, fighting, throwing cigarettes and espresso at each other. I mean, you can imagine it was just nuts.
The man responsible for Lamborghini's modern factory is Ranieri Niccoli. He's the director of production at Lamborghini.
I'm in charge of all the things you are seeing here, so all the assemble of the car and also of the logistic of the parts and all the assembly of the car in Lamborghini.
It's Ranieri's job to get the factory ready for Huracán assembly.
It's really challenging. When a new car is born, it's really something complicated because you have to imagine that a car is made by something like 2,000 parts. All this activity altogether is really complicated.
Coordinating all those parts takes place on 22 stations that produce just 13 cars per day.
We are at the starting point of our assembly line, composed by 22 stations. In each station, we are starting to assemble some parts in order to start from naked cars.
All 22 stations are run by artisanal mechanics.
Craftsmanship is the big word in our factory. We have 2 assembly lines, and these lines are going slower than a highly automated factory.
It's a craftsman's approach to car building, based on perfection.
We have more people doing the assembly, and this is craftsmanship, but also the love of the people.
Typically, the line moves every 34 minutes.
This is a combination between craftsmanship, but also technology. The car has to be unique for each customer.
That quality has a truly national identity.
Lamborghinis for Italy means cars, means passion, means speed, and this is something that for Italian guys, the best place.
Building an Huracán starts with the machine's body entering the line.
So basically here we are starting to assemble the new Lamborghini Huracán. This is the first station.
Bodies are painted off-site in one of 19 colors and arrive ready to hit the ground running. Only at Lamborghini, the onus isn't on speed, but speciality.
It's not an assembly line running through as quickly as they can either. There's only a small number of workstations.
It will take months to ramp up production on the new Huracán, a small price to pay when you're betting your brand on a platform that needs to survive for a decade.
We are in the starting phase of production of the Huracán. So our production is quite low because we are starting to produce the first car.
After you develop a car, then you have all the parts which are coming together until it finally fits with the puzzle and with the quality we want. And then we ramp up.
High-speed manufacturing at Lamborghini still isn't all that fast.
An Italian factory is kind of unique because the Italian cars that you think of are your supercars, are your Ferraris and Lamborghinis. When you get to cars like that, they're being built low volume. It's a slower process.
It will take 2 days to build an Huracán once the factory hits full production.
An Italian car factory, these people are passionate. They want to be there. They are true believers in the brand. They really are passionate about the product.
Like the design team foregoing clay, Lamborghini tests the process of putting the Huracán together with a pre-production series of machines.
So we are doing this job first with the electronic file. We try to figure out how we can assemble the parts, and in the same time we try to design the line in order to say, okay, in this station we will assemble this part, in the other station we will assemble the other part, because we can't assemble all the parts without a right sequence.
Finding the correct installation sequence is just one dimension. Ergonomics and tooling concerns are important too.
Correct means ergonomic, so the worker doesn't have feel the effort to do this all day, and also possible, so all the tooling we need, screw or other thing, has to fit and not to have clash in order to assemble the parts.
All the planning in the world still requires putting it into practice.
So all this activity is done before, and let's say some months before the start of production.
Pre-production starts by checking the quality of the parts arriving at the factory.
We have to check together all the parts coming from these 200 and more suppliers all over the world in this phase.
Those parts are sorted in various areas of the factory and then placed on carts that head directly to the line.
We have 22 stations, and we have to assemble 2,000 parts. You can imagine how many parts per station we should manage. And all the parts are coming with boxes. So every worker in each station has only the parts they need to assemble for one car. They don't have to choose, they don't have to find the right boxes. You receive some trolley like this. In a way, for example, this is a part, which is basically already with support old, with the pictures.
Some of those parts arrive at the early stations on the line, where the Huracan's hybrid chassis starts to take shape.
We are using not only aluminum, but also carbon fiber. And we are using carbon fiber where we need more strength. The carbon fiber has a unique combination between light, weight, and strength. So we were using, in an intelligent way, the carbon fiber when we need more strength for the car.
Carbon fiber really is Lamborghini's specialty. It's what they've really hung their hat on.
It's a cutting-edge material for a very high-tech machine that needs to succeed for Lamborghini to stay alive. In Sant'Agata Bolognese, the pressure is mounting as Lamborghini attempts to replace their best-selling machine. The key to their success comes down to a very earthly material: carbon. A basic element finding new life inside of the state-of-the-art Lamborghini carbon fiber facility.
A couple decades ago, Lamborghini decided to look into carbon fiber. A lot of car companies looked at it, decided it was too expensive, and moved on.
We have an expertise of more than 30 years in the research and development of carbon fiber material.
Lamborghini kept with it. They kept researching it, and today they're on the leading edge of carbon fiber technology.
Like an Italian model, the brand is obsessed with weight and weight reduction.
The cars are getting heavier and heavier over the decades due to different reasons: safety, active and passive safety, comfort, all these things.
Weight is a supercar's enemy because it reduces speed.
Weight-to-power ratio is a really key factor and success for the future. And weight reduction is more important of horsepower increase. If you reduce weight from the car, you will perceive in every single moment, when you accelerate the car, when you brake the car, when you go in a tight cornering, and you really perceive the handling behavior of the car.
The key word for us is mainly carbon fiber, which is a very light and stiff material.
They're building most of the car out of it at this point, and they're exploring ways to use carbon to create structures that are light and stiff.
That exploration results in a brand new chassis that's 10% lighter than the Gallardo's, but 50% stiffer.
In a company like Lamborghini, we can really also experiment a new material because we can offer something special. To give an example, a kind of composite material that we call forged composite, and this kind of fiber is exactly what is used also in the golf club of Callaway.
A supercar sharing carbon technology from a golf club sounds surprising. It shouldn't be, thanks to a very unique agreement between three very diverse organizations.
It's not unusual for car companies to look out to other industries to see where they can find new materials, new processes, but Lamborghini has been so focused on carbon fiber, they've really reached out to places you wouldn't expect: Boeing and the University of Washington and Callaway golf clubs. The weight can affect everything. It affects your swing, it affects how fast your car can accelerate.
The Lambo's strategy for speed comes into focus on the new Huracán. The machine features a hybrid carbon fiber and aluminium chassis, with the front and rear sections made entirely from lightweight alloys, while the occupant safety cell is completely made from carbon fiber. The entire hybrid chassis weighs just 200 kilograms.
The challenge is the joint between carbon fiber and aluminium, in which they has to be designed to resist all the stress we have in the car during the use of the car.
Unlike most car factories, at Lamborghini, they install the interior before the drivetrain. They install the carpet, the center console, and the dashboard.
The gauges in front of you are not gauges, it's an LCD screen. You have one big screen in front of you that does everything. You can configure it to have a big tachometer or a big speedometer. It's very driver-focused.
While mechanics continue to assemble the new Huracán, in another part of the factory, artisans handcraft Lamborghini interior pieces. Just 50 meters from the Huracán line, hides of leather are lined up. The hides arrive at the factory already treated and colored. The range of color options is only limited by imagination. Master leather workers inspect each hide for imperfections. A computer-controlled cutting machine optimizes the number of panels cut from the material, before craftsmen mold and secure the leather to the trim panels. Then they stitch them together one by one. Choose the upgraded interior package, and each artisan will use 30 meters worth of thread. Finally, finished leather pieces head to the line. Station 11 is perhaps the most famous location in the factory, where the Lamborghini V10 is prepped for installation.
Here we are in one of the most important stations of the line, in which we are assemble the engine, so 610 horsepower, with the gearbox.
Lamborghini tradition is a naturally aspirated engine, which has an outstanding torque already at very low revs.
The weight of that tradition rests on the shoulders of Stefan Mazzetti.
Here in Lamborghini, we have the responsibilities of the powertrain, so it means mainly transmission and engines.
Making it work together means creating a one-of-a-kind V10 engine called the LP610-4.
The V10, it is really compact engine, but with a really very high displacement, 5.2 liters. It's naturally aspirated, so very emotional engine. It is really a unique piece of engine art.
Italian high-performance art that's sub-assembled on a jig next to the main line.
Basically, we assemble the heart of the car inside the body.
They install the engine to the LDF, or Lamborghini Doppia Frisione, 7-speed transmission.
It's a super sport double clutch. The gearbox is really compact because we wanted to make it really shorter.
A double-clutch transmission is essentially two traditional clutches in the same case. One stack contains first, third, fifth, and seventh gears. The other holds second, fourth, and sixth. When a driver accelerates in one gear, the other stack engages the next gear in preparation. Shifting gears takes just a few hundredths of a second. Installing the transmission to the engine takes only a few moments longer.
This gearbox and engine then is going to the car in the so-called marriage station.
The marriage looks almost effortless, but installation has to be highly accurate.
We have to be really precise, because if you can see the car and the space between the chassis and the engine, that is really narrow. We are talking about even less than millimeter. So our work has to be precise to avoid any collision.
The tight margin for error is all due to the distinctive mid-engine design layout.
This is a unique challenge for Lamborghini, to put the engine on the back.
They install the oil tank, the airbox, and the drive shaft. To move the machines around, Lamborghini employs a variety of carrier systems.
When the car is just a body, we have basically a carrier system which is taking the car from the bottom. And then the worker, if needs to have the car higher or lower, can adjust the position of the car. Then when the line is turning to the second part, we have this kind of carrier which is taking the car from a hook, because we need also to work on the button of the car.
The first stop after a new Huracán is picked up by the massive hook is Station 12, where the carbon ceramic disc brakes are installed.
Our car is so powerful and the speed is so high that we need something to brake the car in a really short distance. The pre-assembly area in which we are starting from the single components with the help of this automatic tool, we assemble all the parts to create this brake system.
It takes 22 minutes to build each carbon ceramic brake subassembly. Collectively, they can bring the machine from 112 kilometers per hour to a dead stop in just 43.8 meters. That's 2 times the length of a cricket pitch. The factory is built on a lean manufacturing principle.
What we are trying to do here when we were designing the line is to apply what we call the lean manufacturing principle.
It sounds modern, but it's not. The idea owes its genesis to an automotive concept that's over 100 years old.
We try to design a line really compact with all the pre-assembly area on the line, on the side of the line, in a really short distance.
In 1913, Henry Ford radically changes the automotive world forever with the introduction of the moving mass assembly line. The system is a revelation, and it radically cuts down the time it takes to build a machine. But more importantly, it cuts down on wasted motion near the line. By the 1990s, the German auto industry, including Audi, Lamborghini's parent company, takes the process to the next level. They realize that it's not just about cutting down the time it takes to build a machine, but the number of parts at the factory. The less parts weight, the less inventory on hand, the fewer mistakes that can be made, the faster you can build a product. The result is lean manufacturing.
The pre-assembly is here and the assembly point is there. For the engine is the same, for the dashboard is the same. This is something that we try to apply in all our production.
While the theory of lean manufacturing isn't new, Lamborghini's use of it is rather cutting edge.
This philosophy is not new, but it's new in the way in which we are applying, because we have only men. We have people which assemble the Lamborghini. So the challenge for us was to convert this kind of principle born for our huge and big manufacturers to our craftsmanship activity.
The lean manufacturing philosophy is an old idea, but it's managed by a modern technology.
This is a touch screen. Every station is at least one, some station even 2.
The touch screens keep the factory constantly updated on the progress of each machine.
If the worker needs to understand how to assemble something, he can go inside here, he's going a server, and he's written all the cycle plan on the car.
After brake install, they connect the Huracán's power to the machine's four-wheel drive system.
Four-wheel drive is now a Lamborghini hallmark. Once you get to this level of power, it just becomes easier to put it to all 4 wheels.
Using a very special torque converter, the device controls how much of the engine's power is sent to the front wheels.
The challenge is to bring the right power in the front. We choose electronic controlled torque distributor because in this way we can choose in real time the exact amount of torque we want to have in the front and of course in the rear of the car.
The electronic torque converter senses traction loss in mere milliseconds.
There are a lot of ECUs, a lot of power calculation. And these ECUs, these control units, are learning every time what happens for driver behavior, and they are checking also the ground situation, if there is a slipping, if there is ice, if there is rain, and so on. And so they are able to react in very few milliseconds.
Under normal driving conditions, the system diverts 30% of the engine torque to the front wheels. However, if the machine loses traction at the back, 50% of the torque is immediately sent to the front.
If for some reason one wheels or one axle is splitting, you can transfer immediately some torque in the other axle and to avoid maybe oversteering or an understeering.
At high speed, the system alters once again, no longer sending power forward. Instead, the Huracán uses all 100% of the torque at the rear axle.
The power calculation inside the car is something that it is tremendous. The benefit is that you can have a continuous changing in the torque applied to the ground.
Finally, after almost 2 days of hand assembly, a new Lamborghini Huracán is ready for final inspection.
Yeah. You see all the lines and all the edge. We have to respect it to have the maximum precision. We are talking about less than a millimeter in order to see that the line which is starting here is following there on the front hood without any disruption. This is our big challenge when you see all this edgy design, which is fantastic.
It's taken 1,460 days to handcraft that dream. It's taken 4 long years of faith, a continued desire to pen radical shapes, creative engineering solutions, and the means to live outside of the conventional automotive landscape. Finally, Lamborghini's latest creation is ready to attack the track. The Lamborghini Huracán. The machine takes its name from a Spanish Conde de la Patilla fighting bull, but it traces its lineage back to a single machine. The best-selling Italian supercar ever made, the Lamborghini Gallardo. During a 10-year production run, 14,022 Gallardos are sold. To equal the machine's success, the Huracán banks on its Italian heritage.
I think the fact that the Huracán follows the Gallardo so closely in its styling tells us that it was just time for a replacement. It was clear to the company that this was a successful business model, and it was a successful product for the company as a whole.
Today, the Huracán is a 610 horsepower V10 beast.
It's all about the theater. You know, you flip up a little cover to hit a start button, and then the car starts and it's loud enough to wake your neighbors up a block and a half away. Every single piece of that car is hexagonal, and it's just over the top.
It's not often anymore that you get a V10 engine. They're pretty rare. So it's really special when you do find one.
The 5.2-liter engine generates 412 foot-pounds of torque.
They've updated it substantially from the Gallardo. It makes a ton of power. And one of the coolest things they've done is they've made it sound cool.
That sound is a unique Italian tune.
Part of the charm and part of the theater is the noise and the revs.
V10 engines inherently just generally don't sound that great, but you know, the Italians couldn't put out a car that sounded bad, and they've really tuned this one to make it sound like a race car.
The Huracán not only sounds like a race car, but it accelerates like one too. Going 0 to 100 kilometers per hour in just 2.5 seconds. Just 3 times longer than an F-18 jet fighter to 100 kph.
Launch control is pretty brutal on this car. It actually physically hurts. It feels like you got kicked in the chest by a mule.
It will, you know, smack you in the back of the head and launch you down the street before you even knew what happened.
Continue to keep the throttle wide open and the machine will rocket from 0 to 200 kilometers per hour in just 9.9 seconds. An eighth the speed of a bullet fired from a gun.
And the Huracán really carries on that lineage of making it a sports car. This time they really got serious about track performance, about making this car go around a turn faster, and they've added all this technology to it.
That technology helps the machine hit a top speed of 325 kilometers per hour.
It's a car that they've designed to be more of a sports car and go out and actually go around corners quickly and, you know, really be fun to drive.
machine's ultra-low power-to-weight ratio of 2.3 kilograms per horsepower helps it slice and dice in the twisties.
The Huracán is so easy to drive that any novice could go in and get on a racetrack and not have any problem.
We want to have the driver in charge and not the car. What we want is that you are feeling at home immediately, that it fits like a glove, that it's not the car dominating you.
That home features state-of-the-art shock absorbers that adjust the suspension in fractions of a second to give the best traction possible.
These special shock absorbers and these gyroscopes and all these computer programs with the goal of making this car faster around a racetrack and around a winding road.
The Huracán features magneto-rheological dampers. The cutting-edge shock absorbers contain tiny metal particles in the synthetic oil. When voltage is applied, the particles generate a magnetic field, which adaptively changes the amount of rebound the shock experiences. The end result is an infinitely adjustable suspension system.
They really want this to be a well-rounded supercar that you really can go out and drive anywhere and be just as much fun to drive as any of the competition.
That competition isn't for everyone. With a base price of 189,000 euros, the Huracán lives in the realm of the ultra-exotic.
Either you're a connoisseur, at least, or you're not following the beaten path there. You're doing something different.
It started with an argument and a passion for greatness. A little over 50 years later, Lamborghini is still chasing the same dream: to build exotic, exclusive, high-performance machines for the ultra-wealthy. Whether they continue to succeed comes down to a single word: Huracán.
Lamborghini got their recipe right with the Gallardo. It's relatively comfortable, doesn't really beat you up, but still gives you enough sound and bouncing around enough to know that you're doing something bad. It hits the right notes.
It's the newest machine from the house of the Raging Bull, and now it faces the ultimate pressure, replacing the best-selling Italian supercar ever built.
We have half a century in our back, and for us, the motto last year was 100 years of innovation in half the time. And I think this is exactly what we have to look forward for the next decades to come.
The machine ushers in a new automotive era. The name becomes the best-selling vehicle of its day. For almost 5 decades, it has roared to life across America.
The Mustang is a very unique car. There are very few nameplates out there in the car world that have survived a decade, much less 5.
It's a badge that coins a simple phrase.
It's America's pony car.
The current generation has been in production for over a decade. Technology has advanced. Competitors are ready to take its place. Ford needs a new machine.
Mustang is Ford's halo product. It is the product that shows everyone what the team at Ford is capable of building.
The rush is on to build the most important Mustang ever, a 50th anniversary machine intended to go global for the very first time.
Anytime you're doing a new Mustang, there's always a very big fear that you're going to alienate people, that you're going to do something wrong.
This is an inside look as the clock ticks to reinvent the Ford Mustang. For over 100 years, the Ford Motor Company has been building motorized vehicles for the masses. The story starts with the Model T, the world's first affordable automobile. Then the F-150 pickup truck, the best-selling vehicle in the United States for the past 37 years. And finally, the Mustang, the world's very first pony car.
The Mustang is such an iconic car. It's so connected to people's ideas of the country, you know, our national pride.
Introduced on the 17th of April, 1964 at the New York World's Fair, the first-generation Mustang immediately captivates the audience.
The history of the car itself and what it meant to the country, it really epitomizes the sort of optimism of the 60s.
The car is an instant sensation, selling 22,000 units the very first day it goes on sale. A year and a half later, the 1 millionth machine rolls off the line, shattering sales records for the time.
It was clearly the right car for the right time, or it would have never sold in those numbers. Today's best-selling cars don't come close to the volume that the Mustang had in its first year. Not even close.
Over the past 50 years, Ford sells just over 8 million Mustangs.
This was a car that a secretary could drive, or an executive could drive, or your mom could drive.
But the fifth generation of the machine has been in production for 9 years. An eternity in the automotive world. To keep customers coming back to showroom floors, Ford needs to rejuvenate the Stang.
The Mustang is so tied to the company that messing up that is just as damaging in the public's eye as screwing up a mainstream model.
Not screwing up the legend falls on the shoulders of just one man, Dave Perisak.
He's probably gonna hit me for saying this, but he's a little nuts. Then there are just the dudes who want to build the car that they wanted to have when they were 25 years old, doing burnouts in front of the police station to drive everyone crazy. That's Dave.
Perisak has led Team Mustang since 2008 and is the 5th chief engineer for the pony car platform.
I think everybody waits for the day that you get the call to be the next guy for Mustang. It was almost surreal. It was almost something that I didn't believe was happening, but it was definitely a dream come true.
A dream come true that has a major deadline. And just 1,460 days to get it done.
Knowing the 50th anniversary was coming up, the planning started, and so I've been here since day one on the planning of the Gen 6 Mustang.
Lots of cars are billed as groundbreaking machines. The 6th generation actually could be. It's the first Stang planned to be a global platform.
We decided early on to take it global. It's a dedication that we were going to make to the brand and to the company. The world's been ready for us. They wanted Mustang for a long time. The world is watching this car, so just laying awake at night and thinking, you know, did we get that right? Do we need to do more of this? You know, do we have to change this?
Planning the new machine starts with a single team meeting.
The first meeting is realizing what are the goals, what are we trying to achieve with it. Yep. I want to make sure that everything will be available at the dealership before the cars arrive.
Head designer Maury Callum is the man who determines the look and feel of the new machine.
I think we all could sense pretty much that we wanted to do a really special car. We wanted to do something that the people would recognize and people would appreciate.
He's not only a custodian for the Stang, but a guardian for the brand.
It's amazing how much interest there was in the Mustang in terms of where the design was going and how it would evolve. If you screw that up, you know, you screw the company up.
With the 50th anniversary celebration less than 4 years away, the design team doesn't have a lot of time to nail the look of the new machine.
Imagine if it made the Mustang that everybody hated. It's a lot of weight for anybody dealing with a car that's been around so long and it means so much to people.
Mustang is the brand builder for Ford. This is the car that enthusiasts think of first when they think Ford.
In the automotive world, iconic machines rarely stray from proven identities. But Ford needs a striking new machine to captivate younger car fans. Yet the company can't mess up. A formula that's worked for 50 years.
Mustang's had its periods of being consistent to its origins, and then it sort of drifted away and come back again. So then it has really adapted to the time.
There's really actually a great deal of variation over the years in what they've looked like between the 60s, the 70s, the 80s especially, and now the 90s and the 2000s.
One of the keys to the car's longevity has been its ability to transform alongside American culture. Like a true democracy, the Mustang morphs over time.
You can kind of identify the decade, the era by the Mustang. It's changed with American culture.
It's a culture that continues to influence the current Mustang design team.
The good thing about Mustang is, you don't need to write a big, long design brief. You just tell the designers, go and sketch Mustang. And they come back with some great ideas.
Great ideas often start in the past.
We, look back in the history book. That really gave us a rich heritage of design cues. Really beginning with the face of Mustang, of what we call a shark bite grille. So you kind of get this little play on heritage.
Well, one of the things we wanted to really do in this car was bring back the true fastback. So we really have got a great centerline profile to the car.
However, to continue to be relevant, the world's first pony car needs to evolve.
We wanted to make a cleaner statement and give the design a little more timelessness.
This is a car with a lot of pent-up lust for it, and people want to know what this Mustang's going to look like. So, quite frankly, you're damned if you do and you're damned if you don't sometimes. The studio was pretty tense in here.
That tension comes from having to please two different markets at the same time. A year before the design process begins, Ford conducts market research on attitudes about Mustang around the world. US customers want a tougher Stang, while European consumers want a smoother-looking machine. The solution comes down to basic dimensions. The team starts putting pen to paper just over 1,200 days before the 50th anniversary deadline.
We've really worked on the proportions. We've pulled the A-pillars back, we made the hood longer, we made the car wider, enhancing the stance of the car.
It really just helps to give a very hunkered down, assertive proportion. So as we begin our design process, we always iterate with numerous design sketches. This board shows a small fraction of all the design work that we've generated. This was one of the first sketches that really kind of captured the feel of this very modern front end for Mustang. It really has this nice tapering quality and a very strong muscular shoulder over the rear wheel. Kind of really portray this muscular quality in Mustang.
The muscular personality starts to come to life thanks to a classic artistic medium.
Well, the initial step is getting the car down on paper. Say you talk to designers, say sketch a Mustang, you get a lot of enthusiasm, you get a lot of different ideas.
Yeah. Where are you?
And then we go into a scale model phase. We then do a range of scale models, and then these scale models will eventually pick 2 or 3 and go to full-size clays.
The full-scale clay is no ordinary model. It's handcrafted by a master modeler. He will spend hours getting a single line just right. And weeks working the clay until it's perfect.
Then eventually we'll pick the right car for the next stage. Then we'll build different types of models, both the interior and the exterior of that.
Once the clay is dry, it's time to see how the new machine bends light. They use a reflective rack to quickly color the car.
And we go to various hard models like this model here. And then what we call an inside-outside model here, and that's really the time where the big money gets spent and someone signs a check and says, yeah, we're going to go for it.
Utilizing classical artistic mediums, it takes the team a year to dial in the final shape. But with just over 700 days left before the 50th anniversary, Team Mustang needs some cutting-edge tech to hit their deadline. The pressure to finalize the new 2015 Mustang is mounting for Dave Perasek and his team. Every second and every computer chip cycle count. Deep inside the Ford Design Center, in a hidden area, there's a brave new world being born one pixel at a time.
We are in the virtual space of the Ford Immersive Vehicle environment. Even though there looks like there's nothing here, there's actually a 2015 Mustang in this room.
The high-tech room features motion tracking cameras that connect to a 3D headset, which can interact with a virtual world. The 3D system allows Ford to bring the new machine to life before a single car is ever built.
We're looking at the vehicle in a bunch of different iterations. Really brings that spreadsheet to life. It goes way beyond just looking at PowerPoints.
The digital system gives engineers the ability to look inside a full-size machine.
We can cut this vehicle in half, and we can actually look at the engineering structure. There we go. And I can actually look at the engineering structure with respect to the design.
The structure might start deep inside a computer with ones and zeros, but as the deadline to the 50th anniversary grows tighter, the only number that matters is the Stang's planned top speed. An electronically limited 264 kilometers per hour, while the virtual environment lives on the bleeding edge. The most important advance for Generation 6 is actually a rather old technology.
Early on, we talked about the fact that it was time to put an independent rear suspension in this car. It was something that we circled and said we have to do it.
The Mustang's been a solid rear axle for as long as anyone can remember. Pretty much since the day it was made.
A solid rear axle is a dependent suspension design, where a set of wheels is connected laterally by a single beam. It's a time-tested engineering solution that's cost-effective because of its simplicity.
When you have a solid rear axle, one wheel goes up, the other one wants to go down, which means the car doesn't do well in bumps, especially in corners.
An independent rear suspension is a more complicated system that allows each wheel on the same axle to move freely from the other.
All it means is that the two wheels in the back can move in different directions at the same time. One can go up without the other one necessarily going down.
Even considering the change causes commotion in the Mustang community.
In the world of Mustang, there are two cams. There is a solid rear axle cam and an independent rear suspension cam.
In 1965, the original Mustang team intended to use an independent rear suspension. But accountants determined that they could save $100 per car if they chose a solid axle instead.
To keep the price point of that car where it was, they were going to have to pull money out somewhere. Having a solid rear axle has enabled the Mustang to stay inexpensive.
On the track, the solid rear axle helps the machine gain a following on the drag strip. Burnouts become a way of life for the pony car crowd. But no matter how much rubber you burn, time doesn't stand still. Since then, the simple system has become part of the car's ethos. The Mustang is the last sports car with a solid rear axle setup. Until now.
We really wanted to make it a legitimate sports car. We didn't want it to be, seen as a sort of Neanderthal, sort of old-time muscle car.
The car can ride a lot better and handle better at the same time. The drawbacks are a big amount of weight and a big amount of cost, and for the longest time, it just wasn't worth doing that. Having the Mustang, now sold worldwide, all of a sudden it needed to happen.
Maybe 50 years too late, but it's the right thing.
The decision to modernize the rear suspension on the Gen 6 Mustang comes down to a simple conversation with one very important man.
Mr. Ford. Well, when we decide on things like a new front end, ultimately we have to go to Bill because Bill's a part of the board of directors.
Bill is Bill Ford Jr., the executive chairman of Ford Motor Company and the great-grandson of Henry Ford. In the automotive world, he's a rarity because he's the last automotive scion whose name is still on the side of the building.
Bill definitely gets involved. He loves Mustangs. He understands what this car means to the company and what it means to his family. It makes my job a bit easier when I go in there and try to have a discussion about a new suspension system or a new front end. They support me.
While the independent suspension helps get around the corner, it also puts Team Mustang in a bind.
As we put the rear suspension in, we didn't have an intention to change the front suspension at all. The first time we took the car out for a ride, it was very obvious that the rear was outperforming the front, and it was noticeable. I mean, it just wasn't going to keep up.
The 50th anniversary target is less than 2 years away. But it only takes Team Mustang 10 minutes to confirm their worst fears. In order to get the new Stang right, they need to hit the brakes hard.
The bosses don't like to hear it. If this car is important enough, yeah, you can throw a stop in the middle of the whole thing and say, we need to go back and fix this. We haven't done it well enough.
As the days pass until the new Mustang's launch, the engineering U-turn causes drastic changes.
We went back to the drawing board and said, okay, now we're doing a new front suspension. And so the scope of the program started getting pretty big at that point. Before you knew it, it was completely white sheet of paper. We're starting from scratch. Let's do this thing right.
White paper equals a clean sheet redesign. And a very difficult conversation with the boss.
It's very telling that Dave was able to go back to management and say, okay, I put this independent rear in, and all of a sudden the front's just not good enough. He told his chassis guys, listen, if this were the last day on Earth, and you had the old Mustang Boss 302, which was an amazing car, and the new Mustang to choose from, which would it be? And he told them not to stop developing until it was unequivocally the new car.
As the scope of the project increases, the days until the 50th anniversary continue to count down. And so does the team's funding.
We still have chrome DLO.
There's not a hard conversations on just how we're going to do it. Hard conversations around investments, how we're going to fund this. Remember, we had a birthday party to get to. And the birthday party wasn't moving.
A birthday celebration that's planned for the top of the Empire State Building in New York City. The date is set, the plans are made. And now every moment in between matters. Team Mustang has just under 700 days to bring their newest pony car to the market. Turning the next corner will take a brand new engine and a little bit of muscle. 50th anniversary of the world's first pony car is just a year and a half away. In 1965, the original Stang took 8.2 seconds to hit 60 miles an hour. Dave Perisak and his team plan to cut that number in half with the new Generation 6 machine. But a launch off the line is hard to see at the moment. Team Mustang has just hit the reset button on a clean sheet redesign. While they struggle to solve the new suspension problems, other engineers tackle more muscular concerns.
One of the first key questions that we had to deal with is, what are we going to do with the powertrains? What are we going to do with the engines?
The original Mustang's largest engine made 210 horsepower. Today, that doesn't get the job done.
We needed an engine lineup that was going to be more powerful and at the same time more fuel efficient, so that was definitely on the radar.
The team decides on 3 power plants. The first 2 are enhanced versions of classic Ford engines. A naturally aspirated 300 horsepower V6 and a flagship 5-liter V8 that pumps out 435 horsepower.
You know, there's this whole sort of obsession about V8s. Some people still have it, but I think people now appreciate you can get a lot of power out of smaller engines.
But the biggest news is the smallest package, a secret engine designed at the Beach Daily Technical Center. It's a rarely seen high-tech laboratory for engines.
We're always having the I need more power discussion, right? Well, you can never have too much power with Mustang.
The Beach Daily facility is a sophisticated complex where engineers use sand casting and rapid prototyping printers to build one-of-a-kind parts for the new Mustang.
Parts on this vehicle that came through this lab in development are a significant number of the parts of this car.
Almost every single part on the new Stang can be prototyped inside these walls.
The rapid prototyping has been a huge part of making this machine come to life. It helps us to get some answers really quick.
The process starts deep inside another computer. The data is sent to a 3D printer. The system uses a UV laser to harden liquid resin one layer at a time.
I always take parts from a computer model and we slice them up like a deck of cards, and then we make them one layer at a time additively. We build parts from this vat of resin. It's kind of like syrup.
That syrup is so expensive that Ford keeps the exact cost confidential. While the money spent is obscure, the time required to use it is remarkably short.
The intake manifold, it would take a day and a half to build in this machine.
A 15-centimeter tall part takes up to 30 hours to build. Once the accuracy of a part is verified, it's time to build a more advanced and robust prototype part. This time for a running engine.
This is called selective laser sintering.
Next, the team uses a high-tech 3D sand printer. It's just like an inkjet printer, only instead of ink, it uses glue.
This machine takes nylon powder, very fine, like talcum powder, and it spreads a layer of that. The machine will heat it up, and then a laser will come and melt those particles together.
The printer grows components 1 grain of sand at a time and is accurate down to 0.05 of a millimeter. That's roughly 6.5 times the length of a single red blood cell. But sand printing is no day at the beach. Before you can touch the finished piece, you have to dig it out.
This is the breakout station. We get to play archaeologists and dig our parts out. can print a whole box full of parts in about 2 days, so we can have a part back to you in a matter of a couple of weeks. In the old way, it might have taken 4 months to get a part.
Just 5 years ago, turning 3D car data into a functioning engine took up to 6 months. Now it takes just 10 weeks. And for Team Mustang, every week matters as the 50th anniversary deadline approaches.
You build it, you test it, you make sure it fits, and then you go on to the next step.
You know, as we start to develop the engines, we will do some rapid prototyping. You might have rapid prototype parts right alongside production parts, and then we will put it through some testing. So it might go out to our MPG.
MPG stands for the Michigan Proving Ground. This is where new pony cars are run for the very first time.
To be honest, every manufacturer has their own testing facility. Ford's handling loop is pretty awesome.
Inside of a top-secret 16 square kilometer facility that features over 160 kilometers of roads. It's here where Team Mustang tests new engine parts in an early Generation 6 prototype on a unique high-speed oval capable of sustained 320 km/h speeds.
You know, it'll do some durability runs, and they'll run it through its paces. Then they'll bring it back into Beach Day, and they'll tear it down, and they'll say, how did everything perform?
To test it, the team puts 1.5 million kilometers on the new engine, the equivalent to nearly 74 years of everyday driving. Some is done very slowly, some is done very smoky, and some hits the edge of the performance envelope. During the machine's 4-year development process, engineers tear down over 120 engines, scientifically looking at each and every piece until the design is just right.
If something, in fact, is not durable, or if it is falling a bit short of our target, then we'll go back and we'll actually re-engineer it, and we'll go through almost that whole process again. At the same time, they've got me screaming at them, saying, I need more power, so now they're trying to engineer, more power. It just keeps going round and around.
With just over a year before the new machine's introduction, the team continues to test the engine on the track. Meanwhile, new concerns emerge.
Just because you go fast, just because you are having fun and driving, we still want to make sure this car is the safest possible.
To make the Gen 6 machine the safest Mustang ever, the team focuses on the new US roof crush standard. The law mandates that all new machines must hold over 3 times their weight should a car flip over in an accident.
We actually are going to achieve 4 times the weight of the car.
To exceed the government standard, Team Mustang uses a new cutting-edge technology called hydroforming to make the machine's roof rails. The engineering team turns to Schuler, a German company that first started bending metal in 1839. Today, they produce a variety of cutting-edge stamping solutions.
You want to bring roof lines lower and you want to sleek things out, you definitely have a bigger challenge to meet things like roof crushing. Hydroforming is one way to produce an extremely strong, very efficient structure.
Hydroforming is an advanced way to press metal into extremely lightweight and structurally stiff pieces, using heavy weight and water.
We start out with a round tube. Then it goes through a bending process. So the next step would be to put this tube into a hydroforming die. These here would be the lower die, the upper dies. Once the tool is completely closed, that's when we bump up the water pressure to over 20,000 psi.
20,000 psi, or pounds per square inch, is almost 500 times the average car's tire pressure.
In order to form this part, using the pressure that's in there, that requires 3,200 tons of force. So that force is like 1,000 cars stacked up on top of this die to hold it closed.
When we take this part out of the die, it wants to go back to its original shape, what we call as a spring back.
The stamped tubes spring back to their original shape by up to 5 millimeters. That's roughly 50 times the height of a single strand of human hair. It doesn't sound like much, but with just over 365 days until the machine's 50th anniversary. The only thing that's more exact is the margin of error for Team Mustang's birthday celebration. It's been nearly 1,400 days since Team Mustang started planning the 6th generation machine. Now, mass production is just around the corner.
So just an update on where we are on the program, guys. I think everybody knows that we're heading into the TT build for the convertible and the PP build for the fastback.
A PP build is a pre-prototype version of the machine. A small batch of 100 cars to ensure everything is going according to plan.
My job is to make sure that I'm keeping everybody focused and on track. See me in my office, we go through all the details. I want to know what the team's plan is to get to line 90. Don't meet with me on Friday to tell me why you can't get it done. Meet with me on Friday to tell me what you're doing to get it done and what help you need. I am a bit of a football coach in a way, right? I've got to keep their morale up. I've got to make sure that even in the hard times that they understand why we're doing what we're doing. I just want to make sure, guys, that we stay on top of that testing that's completing so that we don't get ourselves into a bind. That meeting is actually one where we set the whole pace for the program. Where are we at in the program? What's coming up next? What big decisions do we have to make? No, guys. So that meeting gets a little heated at times, or, you know, we'll call it energized.
Not having the part on the bomb doesn't help anybody right now.
I don't want to talk to engineers. I don't want to sit there and go through the details. I want to ask why he can't get the work done.
The meetings can be tense. A lot is on the line for Team Mustang, and the company, too.
If the new Mustang failed, Dave would be out of a job.
And I don't need to go to an executive director so that he can tell us that we need to go faster.
Those were the nasty, everyday 3.5, 4-hour meetings in the studio where we cycle team after team. Let's start one at a time. Chrome yellow. What are we waiting on?
When you have passion, it doesn't just happen in one meeting. It's all day long, right? Yeah, sometimes the passion is very prevalent. Do me a favor, don't bring this in my Friday discussion, because if it's in the Friday discussion, it won't be a good discussion.
Every part on this car has been at least debated 10 times. It's going to be a while before the seat guys and the wiring guys and everybody get there. There are several parts in this car where we are running on the ragged edge. I mean, I should say word fought, but we debated every 0.5 millimeter on this car to make sure that we are optimizing to the last 0.5 millimeter.
While the engineering team obsesses over millimeters and the pre-production team focuses on prototypes, the pressure is palpable.
We really are spending a lot of time in the prototype stage, in the development stage, but there's a lot of pressure in the launch phase.
Before the Mustang team can start mass producing the Generation 6 machine, they have to learn how to hand-build it.
The plant's got a big responsibility in making sure that we can build the unit the way it's designed. So we get involved very early on with the design to make sure it's manufacturing feasible. And then we get involved with what's called VP build, virtual production build.
The virtual production build takes place across the street from the final assembly hall, inside a clandestine prototype building that the public never gets to see, known only as the pilot plant.
We have a team of product specialists that get involved with the VP build up at the pilot plant. Now, this is our build prove-out facility. This is where we first get an opportunity to take the parts and the process and get our product specialists involved with doing a static build of a vehicle.
But we'll build a batch of cars and then we'll stop and we'll do some testing, and then we'll build another batch and stop and test.
The pilot plant is a secure facility where the pressure mounts for Team Mustang one bolt at a time. The perfect place to test fit parts on the new Mustang.
If we can learn how to build a vehicle statically, then we can transfer that knowledge onto the assembly line. So they're in there proving out the production processes and getting their hands on the parts and the way the vehicle goes together at a very, very early stage.
Everything is identical to the final assembly hall, except for one small detail. The line never actually moves.
You can see we've got a version of each one of our conveyors. And we have all of our tools right in this building, so we can prove out the process right in here before we have to take it to the assembly line.
After many months of trial and error, the pilot plant prototypes are ready to hit the road. It's time to take a trip back to the Michigan Proving Grounds, where Team Mustang puts the new machine through a variety of paces, including testing a brand new feature that's not available on any other machine. Line lock, a factory-enabled burnout control.
Why not, number one, is why wouldn't you do it?
It's juvenile, it's moronic, it's awesome. And it's one of the reasons why I love the Mustang's engineering team.
The line lock system lets weekend warriors properly warm up their tires at the drag strip. Something that's not exactly condoned by the machine's warranty. But in the battle for pony car supremacy, every new feature counts.
Line lock serves zero purpose at all for no reason other than just to go out and be a hooligan.
Why is this the ultimate hooligan's car? Because I think many of us, we haven't left high school.
Once they first started putting big engines in them, they haven't looked back.
Today, that big engine is the 5-liter V8, which cranks out 435 horsepower and 400 foot-pounds of torque. The 5-liter Mustang launches from 0 to 100 kilometers per hour in just 4.5 seconds.
The new Mustang is shockingly refined. It can compete on the merits of quietness and smoothness.
But the ultimate surprise is the all-new EcoBoost 4-cylinder engine.
It was specifically designed for Mustang. You can get V8 type power in this case with a 4-cylinder engine and produce 33 miles per gallon. The previous V8 was cranking out 315 horse. We're gonna be doing that with a 4-cylinder now.
The EcoBoost offers V8 power with 4-cylinder fuel economy.
Fuel economy is certainly a bigger concern in Europe than it is in the US, and the Mustang possibly couldn't be sold in Europe without that Turbo 4.
But it's the revamped suspension that adds a new edge to the Mustang, a system that at one point stopped development.
They've bitten the bullet, they've spent the money, and designed an all-new rear end that really is going to make this car that much more of a sports car. It's really going to unlock a lot of potential in this car.
The new independent rear suspension helps sling the Stang around corners and down straightaways. Punch the pedal to the floorboard, and the GT will hit an electronically limited top speed of 264 kilometers an hour. It's taken over 4 years of painstaking design, engineering, and testing. Team Mustang is ready to put the all-new Generation 6 machine into production.
Each build, we improve upon our training and our processes. Then we carry it all the way up through MP1, which is mass production. The orchestration of the parts coming together into the process at the right time, that's the magic of manufacturing. Because every part's produced for a certain serial number of a vehicle. So having those parts arrive to the vehicle at the right time just takes a tremendous amount of really good integrated systems work to make that happen.
After more than 4 years of hard work, all of that magic comes together on the 17th of April 2014. The very first mass-produced Generation 6 Mustang finally rolls off the line. Just in time for the machine's 50th anniversary. A celebration planned for the top of the Empire State Building, where 50 years to the day, Ford introduced the 1965 Mustang. It's a date Team Mustang couldn't miss, for the newest variant of a car coined the phrase pony car. But today is no longer showcasing merely American muscle. Now it's a global high-performance competitor. And how it will be received is up to car fans around the world.
Say what kept me up at night was just making sure that we did it the best that it could be done. But it's also something that you never forget, that you're gonna get a report card from everybody. The report card is from the whole world.
It's a mechanical sculpture inspired by wind and built to echo flight.
Pagani is definitely the jet fighter of the hypercar world.
A hypercar that's equal parts high performance and artistic masterpiece.
It's a one man's vision, and you see that in every single part of the car.
Ultra exotic art that comes with an ultra hefty price tag.
And there are expensive cars, and there are really expensive cars, and then there are cars that cost well over $1 million.
Art and engineering that transcend the realm of the supercar.
He's taking it to the next level, where he's setting his supercar apart by trying to make it as perfect as possible.
A piece of automotive perfection called the Pagani Huayra. Nothing about this car is ordinary. Its engine cranks out 730 horsepower, almost double most sports cars. It has a top speed of 372 kilometers per hour, 1/3 the speed of sound. It costs 850,000 euros, nearly 34 times the price of an average car. The Pagani Huayra is one of the most exotic hypercars ever built, and it's all the dream of just one man.
My name is Horatio Pagani. I'm chief designer at Pagani.
In the small Italian town of San Cesario sul Panaro, Horatio Pagani is leading an automotive renaissance.
For the last 125 years of the automobile, the most special cars have come from the visions of one man.
Horatio Pagani really fancies himself an artist as much as an engineer.
It's one guy, and it's his vision of a supercar, and it's a world crowded with supercars.
This is the home of Pagani Automobili, where Horatio Pagani has set out to do the unthinkable, build his very own supercar company.
Pagani kind of came out of nowhere, much like Lamborghini did many, many years ago.
In 1999 at the Geneva Auto Show, Pagani takes the world by storm when he introduces his very first car, the Zonda.
I was at Geneva Motor Show, the quintessential automotive show amongst all the car exhibitions, with a car designed, built, and planned by me.
The machine wows critics and car fans alike.
all of a sudden here's this car that's so great to look at and to listen to and observe and touch and feel that it captured the imagination of car people all over the world.
The Zonda is an ultra-lightweight, mid-engine exotic, featuring a hand-built Mercedes-Benz AMG V12. The machine becomes a poster child for a new automotive term, the hypercar.
I'm very pleased that because of the Zonda, a new category has been created, the hypercar.
For years, the number of machines capable of breaking the 300-kilometer-per-hour barrier was small. And for good reason. At that speed, a car covers the length of a football field nearly every second.
Supercars back in the 80s could do 150, 180 miles an hour maybe. Now your standard supercar will do over 200 miles an hour. We've started using the term hypercars.
One of the cars that helps define the new term is the Pagani Zonda.
Until the Zonda, hypercars didn't exist. After the Zonda, we now have the hypercar.
We're calling these hypercars, for lack of a better word, because we're well over 700 horsepower. Just extreme territory, extreme cost, extreme power, extreme performance. Supercar isn't a strong enough word. It's a hypercar now.
The 2000s were very prolific years in the hypercar world. Those years saw the birth of extraordinary vehicles, built by the premier designers.
Today, there are at least 30 cars that can break 321 kilometers per hour. The term hypercar distinguishes the truly high performance and exclusive from the merely out of reach.
I'd like to think that a hypercar is more exclusive. What hypercars do differently is they make the whole experience special. The inside's nice, they're really crafted well, they're beautiful, they're not just there to go crazy fast.
At first, both Horatio and his Zonda are dismissed by critics, since the company has no track record.
When we first saw the Zonda, we all kind of thought, oh, that's interesting looking, we'll never see it.
While the Zonda shocks the world, its success shouldn't. Horatio Pagani has been beating the odds for a very long time. Born on the 10th of November 1955 in Argentina, Horatio builds his first race car at the age of 20. By 1983, his passion for speed brings him to Italy as the chief of engineering at Lamborghini. His crowning achievement is the Countach Evoluzione, the world's first car with a carbon fiber frame. Horatio sees lightweight carbon fiber as the future of the supercar genre. His bosses at Lamborghini disagree. So in 1991, Horatio leaves to start his own firm.
It takes a strong person to form a company and stick to what you want and make sure that the final product comes out looking like what you wanted it to with all the compromises inherent in engineering a car.
Horatio's vision is to do the impossible, start his own supercar company. A feat that doesn't happen very often in the automotive world.
Pagani has created a brand out of really nothing, and it's an amazing thing.
Pagani is a little bit more on the side of art and theater than perhaps some of the other titans of the automotive industry, but he's definitely one of them.
Exact figures are elusive, but in the brand's first 15 years of existence, they sell around 150 Zondas.
You're never going to see another Pagani at a red light next to you, and I think that's part of the appeal.
Those 150 machines only end up in the hands of the wealthiest individuals in the world.
Pagani exists in a really rarefied air. Only the richest guys in the world who really love cars have one of these.
Owning a Pagani not only requires tremendous wealth, but also an appreciation for the machine's styling.
Pagani has sort of carved out a niche in that world, and he's building his own thing, and his customers are sort of part of that vision now.
15 years after the machine's introduction, the Zonda is growing long in the tooth. And when you build only one model, that can spell financial disaster.
The biggest risk for Horatio Pagani is that people get tired of Paganis. He's got a very niche business. He's selling a small number of extremely expensive hand-built cars to extremely wealthy customers. And extremely wealthy customers can sometimes be very fickle.
With the Zonda aging, Pagani's ultra-exclusive customers clamor for a new machine.
I mean, you've got to have a follow-up act.
Horacio Pagani has spent 15 years basking in the glory of a universally revered hypercar. Now he needs a follow-up. His answer is to start from scratch. Focusing not just on higher performance figures, but also a greater artistic expression.
Entrare proprio in tutti I dettagli.
To be immersed in all of the details, even the most hidden. To try to convey the art behind it.
It takes 5 arduous years to perfect the Huayra's styling.
E questa macchina doveva esprimere tutta la creatività, tutta la fantasia mia e
This car needs to express all the creativity, my imagination and that of my team, and all of the highly skilled labor and artistry of all the artisans who work at Pagani and at our partners.
The Pagani design team creates 8 scale models, as well as 2 full-size models. Each evolves the machine's look until Horacio is finally satisfied.
Quando invece pensai alla Huayra, pensai a una cosa diversa.
When I thought up the Huayra, I thought of something different. A different engine, inspired by the idea of the wind. Different weight distribution, measurements, suspension, frame, all completely different.
The bodywork is styled by Horacio himself. The standout feature is a 2-part active aerodynamic system.
Una nuova sfida.
The new challenge. This is the first car in the world with active aerodynamics. These flaps move, and the car changes its distance from the ground because it works like a wing.
The machine features airplane-inspired flaps at each corner. The flaps move independently and alter the amount of downforce the Huayra experiences. Downforce is similar to the principle of lift that helps airplanes take off, only it's turned upside down. Instead of taking off, downforce pushes a car into the ground.
The people working on my team, they can perceive the laws of physics, geometry, math, science, technology, all through an artistic lens.
The second part of the aerodynamic system is harder to see, but perhaps even more important. The suspension automatically lowers the front of the machine to increase the Huayra's angle of attack. Together, the 2 parts of the active aerodynamic system reduce drag. Drag is the amount of resistance an object faces as it travels through the air. The lower the drag, the easier it is to slice through the wind, and the faster it can go. The Huayra's 2-pronged approach reduces the coefficient of drag from 0.37 to 0.31, effectively shrinking the machine in size by 1/6. Davide Testi is the chief test driver for the brand. He's responsible for testing every component of the new machine.
8 years ago, Ms. Pagani started speaking about the new car, and after this, we can start the project.
Davide tests the new machine for 4 years.
It's not too easy to build another supercar like Zonda.
He drives over 1 million kilometers in one of 5 Huayra prototypes. That's 46 times the average distance an American travels per year in a car.
It's very strange because it's like the first meeting with a new goal, you know?
After 7 years of hard work, the Huayra is introduced to the world in 2011. It immediately puts other exotic car manufacturers on notice, raising the bar in every measurable automotive category.
When it debuted in Geneva, it was, the star of the show. Everyone was surrounding it, everyone wanted to check out every single little tiny detail.
The Huayra blasts from 0 to 100 kilometers per hour in just 3.2 seconds. It hits 200 kilometers per hour in just 9.8 seconds. In a mere 25.8 seconds, it crosses the 300 kilometer per hour mark. That's faster than a jumbo jet at takeoff. To power the Huayra, Pagani once again turns to one of the most legendary automotive brands in the world.
So the engine comes from Mercedes-Benz. It comes from their performance subsidiary, AMG.
We have many things to offer for him because love for details is what we like too.
When Horatio first discusses the new machine with the famed engine tuners, he asks for a newer, more powerful V12 engine.
The Pagani V12 is a very interesting and exciting story for AMG. We got the order to make the highest performance engine we ever made, and that was the challenge we are searching for every day.
The team spends over 1,000 days exploring possibilities. Their response is simply called the M158.
AMG is special because they've always concentrated on insanity. AMG stuff has always been about lunacy. This company exists to make insane cars, insane engines, and, the proof is that it wound up in an insane Pagani.
AMG's solution is to add turbochargers. Something that Horatio Pagani isn't keen on, because historically, it adds a small delay in throttle response called turbo lag.
There's the special turbo lag, everybody knows it, we don't like it, and nobody wants to feel the turbo lag, of course.
The turbochargers also offer tremendous efficiency. The Huayra uses around 20 liters per 100 kilometers, unheard of fuel economy for a hypercar.
Normally, it's not so easy in the life of engineers to have two advantages, but in this case, we have more power and less consumption. We don't have much time to do it. That was a little bit pressure.
It takes the AMG team 3 years to perfect the power plant.
It's Mercedes' most powerful modern engine, and in the Pagani, it makes even more horsepower.
Pagani's V12 produces almost twice as much torque as a Ferrari 458, and 2.5 times the grunt in a base Porsche 911. All that power is built in a very artisanal way by one man on one assembly line.
It's not a regular production line engine. It's one guy who builds this engine, and that's something really special.
Building the Huayra's engine is the responsibility of Michael Kubler, one of just 2 men who are allowed to put Pagani engines together.
It's really an honor to be one of the 2 who are able and allowed to build it.
Even when you're a talented engine builder handcrafting one of the rarest V12s in the world, you still get starstruck.
I've met him once when he has showed us his Pagani Huayra. I'm a petrol head, and to see one other petrol head who has passion for cars, it's crazy, it's an honor.
From start to finish, it takes just 8 hours to build a Pagani V12 engine. That's roughly 90 horsepower per hour. And there are more than 500 parts. The first step is swinging the massive engine block onto a specially designed cart.
After that, we get the crankshaft in it.
Then it's time for 12 very special pistons, each one installed by hand.
After the crankshaft, we made the pistons.
The timing chain is added, oil pan, and cylinder heads. Michael installs the steering case and engine covers. Finally, the brightest piece on the engine, and it's most important, the turbochargers.
The turbocharger takes the air that normally comes into the engine, compresses the air, and brings it compressed into the engine.
The turbochargers force 2 times as much air into the engine as a normally aspirated power plant. During a top-speed run, the engine will consume 400 liters of oxygen per hour. That's 70% of the amount of oxygen a human being breathes in a single day.
After the turbo, the air intake, which is very special for the Pagani Huayra, has a bigger one than the other V12 engines from AMG. After the air intake, we have the gold cover, like this, what is a symbol of art, would I say.
Engines are run at full speed for 30 minutes. Then, the massive engine heads to Italy. While the engine is being shipped in another part of Italy, over 400 unique parts are exquisitely CNC milled by sub-supplier Aspa.
Here at Aspa, we manufacture many parts for Pagani automobiles.
What lies within these walls is a candy store of the choicest automotive bits.
You might say the pieces are artisanal, but achieved by industrial means, because these are very small batches produced with great precision, a precision that even transcends industrial standards.
Not only are the parts extreme, but the tolerances are too.
The tolerances requested are on the order of thousands of millimeters, microns.
1,000th of a millimeter, or 1 micron, is a little smaller than a spiderweb strand.
Absolutely. It's a modern sculpture. Obviously, we can't compare ourselves to Michelangelo, because he worked with his hands. That was much more difficult. We can say this is a modern sculpture, achieved using CNC machines.
Aspa applies that level of precision to over 400 parts for the Huayra. CNC milled parts aren't just good for outside appearances. Inside the cabin, the ignition key is milled from aluminium as well, at a cost of 2,900 euros. When all those expensive pieces are finally finished, it's time to ship them to San Cesario sul Panero, Italy. Automotive visionary Horacio Pagani has spent 7 years trying once again to push the boundaries of the hypercar envelope.
We're at a point in the history of the automobile where everything is fast. When you have a family sedan that can keep up with a 10-year-old supercar, what are you going to call the stuff that's one step ahead of that?
Pagani stays ahead of the competition 1 cut, 1 bolt, and 1 car at a time. Inside of a facility located on a tiny side street in a small industrial park, where 53 craftspeople endeavor to be perfect. While the building might be small, the ambition is grand.
La Huayra è una macchina che racchiude.
The Huayra brings together so many new technologies, particularly in the realm of composite materials. Technologies that have been studied for years. I've worked with them for 30 years.
Horacio Pagani's passion for carbon fiber starts as a young man. For the next 30 years, he masters his craft. His speciality is creating a carbon fiber monocoque.
A monocoque is a carbon fiber tub. It's basically the passenger compartment in the safety cell.
Monocoques are first developed for Formula One race cars. Eventually, they find their way into exotic hypercars.
It's basically how race cars are built.
Inside the Pagani factory, craftspeople build the Huayra's carbon fiber tub by hand.
We're in the section where we construct the carbon fiber components.
Carbon fiber monocoques are extremely expensive to build. But Pagani's cost even more.
Pagani weaves in titanium, and the titanium makes that mat stronger, so the plastic portion is less. Less plastic means less weight and more strength.
The carbon fiber titanium monocoque is the company's signature feature. Every single one is made in-house.
Pagani doing all their carbon fiber work in-house is an incredibly unique thing today.
The process starts with a roll of cloth.
Now we're looking at the area where the material is cut, which takes place in a separate room from the regular production process. Our material, our carbon fiber, comes to us in rolls.
It's basically a bolt of cloth and glue, and you put those two things together and you get an incredibly lightweight and strong structure.
They use a custom cutting machine to maximize the material and limit waste. Once shapes are cut, unique kits are made up of 222 components.
La Huayra è composta da 222 componenti. The Huayra is made up of 222 components made of composites. Each component is made up of, on average, 4 layers of carbon fiber. I say on average, because some of the components are made up of many more layers. But I can't say much more about that because it's a trade secret.
Once the carbon fiber kits are done being prepped, they head to what's called the clean room.
In this department, the pre-cut carbon fiber skids are applied to the molds. This is where the piece takes shape.
The pre-cut shapes are applied to a mold and resin is added before pressure is applied.
Once we finish the process we call lamination, that is the multi-layer phase, all of these layers are pressed together. Why? To create a vacuum.
It takes 5 sheets of carbon titanium to make one Pagani Huayra tub.
The sheets of carbon titanium used in the Huayra make posh wallpaper look inexpensive.
Just one sheet of this carbon titanium weave is $500 per square meter, and it's only 1 millimeter thick.
After the molds are vacuum sealed, they're ready for the autoclave, a large oven where heat and pressure combine to bake the Huayra's carbon fiber parts.
Now we're in the section where the components are placed inside the autoclave.
The autoclave cooks Huayra pieces between 120 and 145 degrees Celsius.
This piece here, if we expose this to 150 degrees Celsius for 4 hours, it will become deformed, and the resin, which has hardened, will return to a consistency of honey.
To make a carbon fiber piece, you basically take this mat of carbon fiber fabric, you cut it to the right size, and you put it in the mold, you squeeze down on it really hard, and you bake it in a vacuum.
Each carbon fiber body part is hand-fitted and expertly shaped in a quality control department that's more high-tech laboratory than factory.
Carbon fiber as a fabric isn't beautiful, but to get the pieces to match up when you have this 3-dimensional weave is not easy. And the seams on this car are invisible. Their pieces are matched up against each other, and that's what you're paying for. If you're the type of person to understand that, you'll really appreciate it.
I mean, you see the way the carbon fiber weave is all fitted together, how it all works together. It's just impeccable, impeccable detail.
The importance of the carbon fiber can't be understated.
This brick, you see, represents what we're doing with our vehicle. It's a brick that weighs less than 1 kilogram, and it has structural characteristics that are identical to this steel, which weighs 4 kilograms.
The 4-to-1 weight savings helps the Huayra reach incredible speeds. Once the pieces are perfectly fit together, the bodywork heads to paint. while the monocoque heads to the final assembly area.
We are on the first station for the assembly line for the Pagani Huayra. We can see some of the components here. This is the front chassis.
Well, it's an amazing thing to put together a car. A car has more parts than you can probably imagine.
Ordinary automobiles are made up of around 3,000 parts. The Huayra has over 4,700.
When they say there's 50% more parts in a Pagani than there is in a typical car, it's really not that surprising because there's parts on top of parts on top of parts.
Each part speaks to one man's obsessive vision to create automotive art.
I'm not going to diagnose the guy, but he certainly seems to be on the OCD spectrum. The car is just that detailed and perfect. It's just crazy. I mean, it's obsessive.
The attention to detail is expressed by the handwork done by expert craftspeople.
It's hand-assembled. Everything about this car is meticulously thought out. The attention to detail in the Pagani is off the charts, and that's what you would expect for a car that costs so much money and takes so long to build.
In a mass production factory, a new car can roll off the line every 60 seconds. At Pagani, it takes 3 months to build just one Huayra.
They have that kind of buyer who's willing to wait for something that's perfect.
Behind every Pagani component, there is the thinking that is art and science can work together.
Every build starts the same way, with the carbon fiber monocoque.
One feature that I believe that is very interesting that the fuel tank, it is installed inside the monocoque.
They move the front subassembly into place, then bolt it together using special titanium hardware.
Every titanium bolt has the Pagani logo etched on it. I mean, that's the kind of attention to detail that you don't see that anywhere else.
The obsession with details comes with a heady price. A single titanium bolt costs 68 euros, and the Huayra uses 1,200 bolts. Each is lined up precisely.
Titanium bolts that are all indexed in a certain way with the Pagani logo laser etched in them.
A single set of titanium bolts is worth over 81,000 euros, 3 times the average yearly salary in Italy.
You sort of get the feeling that Horatio Pagani wants to use the best, most expensive materials on this car. It's almost like the guy is looking for challenges for himself.
The front subassembly also carries 2 of the Huayra's carbon ceramic Brembo brakes.
We equip our vehicle with a carbon fiber brakes. We have used the carbon fiber brakes because the performance is higher than a standard brakes, let me say.
The 380mm carbon ceramic brakes give the Huayra awesome stopping power.
We can start our car from 300 kilometers per hour to 0 in less of 7 seconds.
And a single brake disc is 1/10 the length of an entire Volkswagen Beetle.
Typically, a car with a really, really great braking system has 4 times the braking power of the engine.
4 times the Huayra's V12 engine is equal to almost 3,000 horsepower. That's nearly 2 megawatts of energy, enough juice to power 1,000 houses. It's taken Horatio Pagani 7 long years to bring his newest hypercar creation to life. But when you're building automotive perfection, for nearly a decade, Horatio Pagani has been preparing to replace one of the first hypercars. His response is the Huayra, a machine that can blast from 0 to 100 kilometers per hour in just 3.2 seconds, thanks to an AMG V12 engine. The 730 horsepower V12 is bolted to the Huayra's monocoque chassis during rear subassembly installation. There's no clock ticking or rush to get the job done. Each piece is hand-fitted and then refitted until it's perfect. Even though putting the Huayra together is a slow and methodical process, shifting the machine is not. The transmission switches gears in 60 milliseconds, half the time it would take light to travel around the Earth's equator.
The Huayra has a 7-speed, single-clutch automated manual. Basically, it's a manual that is mechanized and robotized, and it comes from the same company that builds Formula One gearboxes.
Unlike many high-end supercars, the Huayra doesn't use a double-clutch transmission.
The official company line is that a dual-clutch unit would have been too heavy.
When Pagani engineers first study their transmission options, they discover that a dual-clutch transmission adds 70 kilograms to the machine, almost double the single-clutch transmission's weight.
It's a single clutch, and that means rough shifts. You could probably argue that getting beat up a little bit inside the car is what it's about.
The team shaves weight on another piece of the drivetrain as well, the titanium handmade exhaust. It weighs a mere 10 kilograms.
And you see that exhaust, and it wraps around, and it comes into these really special mufflers. You don't see these mufflers on regular cars. These look like motorcycle mufflers.
The exhaust is handmade, and yet another piece of metal artwork. While work continues on both ends of the machine, other craftsmen focus on the interior. Where the Huayra's aeronautical inspiration is immediately apparent.
When you're inside the car, all the switches are big toggle switches, and you feel like you're in the cockpit of a jet flipping some missile defense or something.
One of the key elements is the openly exposed shifter.
The details in the Huayra are almost like an animal anatomy lesson. He's pulled away all the fat, he's pulled away all the muscle, and you just see the sinews, and that's what you see in the shifter.
The sculptural shifter unit features 60 individual components, and each is on display.
You see all these parts that you'd never ever see in a normal car because they're covered by a console, which is covered by leather. He stripped all of that away, and you see the bare mechanism, which is just beautiful.
Even the switchgear is unique looking.
The gas pedal is beautiful, and the linkage that it moves, nothing you'd ever see anywhere else.
The switchgear imitates clarinet keys. It's just obsessive, really.
Honestly, this cabin is pure concept car. This should never be in a real car because it's too beautiful. The most expensive, best cars in the world are never like this, where every single piece is a piece of art.
The analog instrument gauges are a focal point. Each dial is handcrafted just 35 kilometers away in Bologna, Italy.
The gauge cluster is something that looks like it was made by, like, Rolex.
The fact that the gauges look like a watch face is no accident. They actually are. Chronograph manufacturer Patek Philippe uses it to make watch faces. A set of 4 gauges costs nearly 7,100 euros.
The gauges, they've got a very retro aircraft kind of look, you know, stuff that was functional 70 years ago, but today just looks really cool.
The details in the dashboard are equaled by the distinctiveness of the Huayra's key.
I mean, look at that. It's a billet aluminum piece of gorgeous art with an unlock and lock button on it. Pull it apart, that's the part of the key you shove in.
Horacio Pagani's obsession with weight reduction can be seen in each and every part of the Huayra, even the stereo speakers. The units are built by Sonos Faber, a famed audiophile company located near Vicenza, Italy. The company's name loosely translates to handmade sound. A pair of their household speakers costs up to 157,000 euros.
The main challenge in the Pagani was to stay within a certain amount of weight, because of course you have an extreme high performance car, and the performance is about the ratio between the total weight and the power of the engine.
The Faber system features 1,200 watts of power, which is roughly 4 times the power in an ordinary home stereo.
The techniques we use for the Huayra is something unique, to reproduce. We wanted to achieve the maximum possible quality. The task was the weight.
To remove weight, the team focuses on using carbon fiber materials, just like the Huayra's monocoque frame.
We are using carbon fiber for the cone. It's a special sandwich of material, and we use it for the rigidity and for the weight, of course. We started from a blank sheet of paper and designed all the parts inside to match perfectly with the door.
Those doors are as eye-catching as any in the hypercar universe.
You pull up anywhere in a DeLorean or a Gullwing or a Pagani and you open the doors and traffic stops.
Inside the final assembly facility, each gull-wing door is carefully installed, bolt by bolt.
If you're gonna do a parlor trick like gull-wing doors, a supercar or hypercar is the best place to do it because there is no such thing as kitschy or gaudy when it comes to these cars. The more over the top, the better. And frankly, gull-wing doors are about as over the top as it gets.
After 3 months of nearly fanatical attention to detail, a brand new Huayra is finally ready for the real world.
Pagani is a craftsman, and everything he builds is so detailed. Every little part, you get the feeling that somebody really thought about it and stressed over it and put their life into. It's kind of priceless, and you know, here you have something you can drive.
Nearly half of all Huayras will eventually end up in Asia. Another 30% are destined for the United States. Yet no matter which country a machine calls home, there's only one place a Huayra is meant to be.
Basically, this is a street-going Le Mans prototype. It's got active aero on it. It's got 4 ailerons, 2 in the front, 2 in the back, that react to what the car's doing.
The Huayra's active aero system helps keep it glued to the ground.
The idea behind the ailerons is simple. If the flaps go up, they use the wind to push the car down.
The system kicks in between 100 and 280 kilometers per hour to stabilize the car.
Over 50 miles an hour to stabilize the car and to create a little bit of downforce. All 4 come up about 10 degrees.
In the corners, the flaps deploy to keep the car planted in the turn.
When you're going into corners, they can pop up to 20 just to push down on the car and help it turn.
During heavy braking, the system activates again, this time to generate additional braking force.
And under braking, they pop up to 40 degrees as kind of a parachute.
The Huayra's active aerodynamics package gets the attention, but the machine's power-to-weight ratio is even more impressive.
In terms of power to weight, there's no question the Huayra is at the top of its game. There are very few cars that have this much power, this little weight, and are ultimately this fast.
The Huayra weighs a mere 1,350 kilograms.
The Huayra isn't a heavy car. It's 3,200 pounds, and it's got this huge 6-liter Mercedes V12. It's not light either, and the Huayra still manages to weigh 3,200 pounds, basically because it's all carbon fiber.
Pagani's obsession with weight reduction pays off. The Huayra is an astounding 590 kilograms lighter than a Bugatti Veyron.
Yeah, 3,200 pounds isn't a lot. It's basically a little bit heavier than something like a Volkswagen Jetta, like a typical 4-door economy car. And this car has 720 horsepower and weighs that much.
Driving the Huayra is a high-speed, artistic experience, unlike any other.
If there's anything the Italians do better, it's theater. The doors fly open. There are ailerons when you hit the brakes. The car opens up like a clamshell. It's there to say, look at me.
It's a very fast and dramatic performance.
The acceleration is smooth, like when you're sitting on the runway in a jet and they hammer it for takeoff.
The astonishing acceleration has a unique sound, too.
The soundtrack is not like you're used to. You expect a big, loud, thundering exhaust, but this is really like sitting on top of a jet engine.
A jet engine with roots in the highest levels of automotive racing.
You've got a lot of race technology in here. Single clutch, automated gearbox, carbon ceramic brakes, something that F1 uses in a different form.
The racing-inspired tech catapults the machine to a nearly unheard of 372 km/h top speed. Yet the Huayra's speed blasts right past its scarcity.
I've probably driven 2,000 cars in the last couple of years. And I never even thought I'd see a Pagani in person. That's how rare this car is.
I've worked in the industry for 14 years, and I'd never driven a Huayra until today. The only other Pagani I've ever seen was at the Geneva show when they introduced the Huayra a few years ago.
This isn't just a fast car. It's an experience.
That experience starts with a base price of 850,000 euros, has 730 horsepower, and can hit a top speed of 372 km/h.
There's actually a couple of design elements that I think will become really Pagani icons that you're going to see. The 4 exhaust pipes, the 4 headlights, and something else that's really neat is the side view mirrors.
Part sculpture and part jet fighter, and a machine destined to inspire the next generation of automotive enthusiasts.
The world's most perfect woman, where every angle and everything is just art and perfect, and everything she wears is perfect, whether she's wearing it or it's on the floor.
It's a machine that is a testament to one man's vision for automotive perfection.
There's definitely some ego to it, but you know what? The guy started his own supercar company. That's not something that happens every day. Pagani not only built a supercar, he built a hypercar, one of the most expensive in the world, one of the most finely detailed in the world, and he made a successful business out of it. When you pull off that kind of success, you've kind of earned it.